wait for some time and see whether anybody joins. I hope I'm live now. Yeah, I think I'm live. That's good. Do see whether I'm able to hear myself or not. Wait for some time and see whether anybody. Okay, so today let's learn about artificial intelligence. Particularly, we'll see how we can learn artificial intelligence in a shortcut manner. Okay, so because not many members are aware that you need to know the basics of AI rather than coding. Okay, so this is where I'm planning to help you guys out. So what we'll do is I'm going to wait for some time for others to join, but meanwhile I'll also let 3 pointers today, so that people can understand how it works. Okay, fine. What I'll do, I'll try to share my screen. Okay. So I hope you're able to see my screen. So, so yeah, we're good to go. So in today's session, we'll try to cover basic of AI, and then we'll proceed further how we can use Python to learn AI and master the concepts of AI better. Okay. So what we'll do is we'll make a small activity towards the end, just to see your ability of understanding all the concepts, number one, and also to help you out clarifying any of your doubts. Okay, so let's quickly move on to the our first slide. That is this to the right. Okay, so what is artificial intelligence according to you? So what is artificial intelligence? People have asked me over and over again. What people do not understand is that artificial intelligence is not something which is rocket science. Okay, artificial intelligence is there, is being present in today's world from past 60 to 70 years. I say yes, at least 60 years before, artificial intelligence was there, not just in these movies, but in reality as well. And it's not a surprise that there were quite a lot of movies which were done on artificial intelligence. Particularly, there were a movie like 2001 Space Odyssey back in 1960s, I guess. Yeah. So at that time, when people were able to envision artificial intelligence, why not today? Correct? So it's not something which has started of late or something, and which is not a rocket science as such. But there is something more important with respect to artificial intelligence. What is that? Artificial intelligence, when it started back in probably 1960s or 1970s, when it was in R&D stage, people were aware how to pursue artificial intelligence, but the problem back then was there was not much data, right? So if you do not have a lot of data, how are you going to create an AI application? Even if you create an AI application, it's of no value in that, because it does not understand the what is called intricacies present in a what you call it, data itself, right? Even before 1950s, people were using different data points like statisticians or mathematicians, what they used to do is that they used to collect data points from multiple places, and then they used to create some linear equations and linear algebras, and then we used to what you call the create plottings, okay, create linear graphs, and we used to have a lot of hypothesis testings, and there were quite a lot of things which we used to do earlier. Even today we are doing, I'm not saying denying it, but our task, if suppose I was a statistician back in 1940s, whatever I used to do back then, if I find another aid, probably like a virtual aid or could be physical aid or virtual aid, whatever it may be, but if I find another aid, why don't I use that? That is called smart work, right? So instead of be toiling all over again and again just to deduce whether it works or not, rather we can go with some virtual application. That is what is artificial intelligence. But before I proceed further with artificial intelligence, there is something even more intriguing and more important than AI. That people, I mean, even I miss probably in this PPT, but that should be the first thing, and then start with AI. So what is that? There is something called as genesis of AI. That's called data science. What is data science? Actually, data science is not just AI, but also it, according to a American scientist called Drin Conway, what he was saying is that data science is combination of maths and statistics knowledge, having proper hacking skills, programming skills, but more importantly, you should also have a domain expertise. Meaning, if you're from some other background and if you're trying to start creating an application with probably with including statistic knowledge or probably without, but without a proper domain background, how are you going to solve that particular problem? Probably you will solve it, but it may not be optimal. There are quite a lot of challenges even back then and even today. I'm not saying that it is completely out. Even today, there are challenges even within AI or ML, DL, or whatever fields in AI. But that doesn't mean that we have restricted ourselves. We have come across quite a lot ahead than what we were earlier. Now, so if you are having a good statistical background and if you are also having a good programming skills, then probably what I would say is that then you should be eyeing for machine learning. Okay, because you already are aware of statistical knowledge, you can use that statistical knowledge. You can use that probably probabilities or probably your test hypothesis testing or be your linear algebra, whatever it is, use that knowledge to do programming and then move towards machine learning. Now, if you are good in statistics, but also you're good in what you call business knowledge, but not that much in hacking skills, then why don't you move towards the traditional research? But today morning, actually, I was speaking to one of our students. He is actually from a market research background. Okay, so I was asking him, okay, you're already having prior experience in market research, and you also are aware of basic math and statistics. Then why don't you move towards traditional research rather than going towards machine learning? Because though he's ideally from an IT background, probably 10 years back, but from past 10 years, he's not in touch with hacking skills. So if you are planning to move ahead towards machine learning, you still need to have good programming skills. Otherwise, it's going to be very difficult. So I was trying to help him out, understand, okay, it's not just about AI is not only machine learning. AI is also about various other things. There are a lot of things probably will touch base on other things as well. So why don't you move towards your research area itself and master that one particular thing rather than moving towards machine learning, right? So then he understood, okay, this is not just data science is not just about AI or machine learning. I mean, AI is part of data science, but data science is not just machine learning, right? So, and also there is one more angle for it, because tomorrow, probably if you're coming from some pure programming background, probably you're from web development in Python or from C Sharp, .NET, or pure Java. So if you are coming from that background, and then if you're trying to learn data science, so what I would suggest, at least try to have a what is called as business knowledge. Just having programming skills and maths and statistics knowledge alone will not lead you to be a data scientist. Why? Because you need to even have a good understanding about the business. If you do not have a good understanding of the business, but if you have good understanding about your programming skills or the maths and statistics knowledge, still that's what I mean, Drew Conway has highlighted, that's called danger zone, because that is like shooting in the dark. So you do not know what you're trying to solve the problem, and the problem itself could be so complex that it might lead to a lot of catastrophe. So it is better, even if you're from programming background, what I would suggest, at least have a domain knowledge. That's the primary thing. Now, that this is one of the definitions which Drew Conway gave. Okay. So is that the only thing? Answer is no, because that was right back when he gave it. It was around 20 years back. But today, AI field itself has moved far, vast enough. Okay, and data science, which is actually the genesis of AI, what I said earlier, is the gamut of many things, not just about one thing. So that's the reason why I even have given over here. Like, statistical analysis is one thing, but today, along with the machine learning and deep learning, we are also moving towards something called innovative technologies. Meaning, if you are aware of Internet of Things, it's actually it's a what you call physical hardware device which is connected to probably cloud, and then it harnesses AI abilities. Okay, so you can actually if I take a typical example, because this happened with me personally, when I bought a small toy for my kid. Okay, so the toy per se is not having any AI abilities. However, I was just wondering, what if we give the toy an ability to think on its own and then arrive at a result? Then when I was trying to research on that, there's actually already a company called Miko which is doing in a similar area. What it has done, it is actually going to connect. I mean, the toy itself is just what is called a dog. Okay, it's a small dog, but the toy connects to your Wi-Fi and tries to download the data as much as possible. And also, it's like similar to your any Amazon Alexa or Echo dot, similar to any of your interactive devices. It's called VK, which we'll cover later. But it tries to respond to whatever you ask. So imagine if my child is able to understand what the dog says, the toy dog says, and if my child is having fun with it. So you can imagine similar real-time application, how it would be. I have recently come across another real-time application, to be honest, that is called a IoT switch. So what it does is that actually you can actually connect that switch to your plug, and instead of you going to your plug every now and then to switch it on, switch it off, or something like that, because ultimately there is a wear out for a switch, right? So in the long run, the switch wears out. So rather than that, what they have done is they have given the device you can connect to a plug, and that device connects to your mobile through the cloud, and you can actually operate the device using your mobile. So now imagine where it is going to have an impact. Impact in the sense, today probably I will be sitting in one place, okay, probably in office. I can connect to my cloud and to that switch, the plug. I mean to say the IoT plug, and I can switch it on or switch it off according to my need. So if I see that my son is cranking out in the home and while I'm sitting in the office, and if nobody is there to attend to it, so what I would do, I can actually connect from my office to the house using my CCTV camera and see whether he's really having a problem or if there is any concern. If he's just cranking out just because there is no attention or something, what I could do is that I can just switch the TV on right from sitting in the office. Isn't it good? Because that helps not just my child but also me ultimately, because if my child is happy at that particular time, ultimately it is going to help me in the long run. Correct? So this is one aspect of data science. So, and if you ask me where is AI over here, it's just a cloud technology. At the end of the day, what I could do is that there is something called as analytics which is running in the background. It also you can also check how many hours your child has watched the TV or how many hours probably he was cranking out. All these type of analytics is going to be key in the future. Why? Because based on that, what you can do is you can take a decision whether you want to have a particular channel. Okay, if my son sees cartoon channels, probably he gets silent. But if he sees some other channels, probably he will not. Or in cartoon also, probably only one type of cartoon channel he likes the most. Probably the other one he may not. So I can just buy the subscription for the one which he likes the most, right? So ultimately, at the end of the day, I'm going to save quite a lot, and also it in turn gives one more thing, hidden aspect. You can also ensure that your TV is switched on and off in the optimum manner, and you can save your electricity at the end. Correct. So there are quite a lot of advantages. If you see in the real world aspect, not many people understand this in the first place, but as you explore it further and further, you'll be really amazed to see the kind of impact that it's going to bring in the future. And there is something called as computer engineering. So that is nothing but a simple computer engineering. I will not take much time on that because it's still in the research arena. Yeah, but let's look into the next important angle, that's called data science lifecycle. So data science lifecycle, in the sense, if I take an example of a typical data collection process, okay, let's even before proceeding with the data science lifecycle, let's understand about the data collection process in the real-time scenario. Forget about the online or any other place. Back in 1980s to 1990s, what people used to do is that people used to give the forms to the other members, trying to understand whether they used to get a feedback in hand. So have you seen that? Probably if you are from that arena, actually you'll be able to know. So they used to give the feedback form, means it's a physical feedback form. People used to write, and at the end of the day, people used to collect that feedback form and then arrive at a decision. So today, similar thing can be done online, right? So the advantage of having moving to online is that you can collect the similar thing. You can, instead of giving a physical form, you can just give an online form. But at the end of the day, you will be able to collect the data, number one. At the same time, you can also arrive insights out of the data, which was not the case back with the earlier, right? You used to just get the data, but probably you'll be able to take a decision based on some mathematical calculation. I'm not denying it, but it was not that easy as what it is today. And due to that, what has happened is that there's a lot of booming in the market, particularly in the data mining applications. People around the world are trying to get the data, as many as data, and that data itself has become humongous today, and it has led to a whole new opportunity in big data. So that's a whole different topic which we'll take later. But so coming back to the data science lifecycle, collecting the data itself is the primary thing. If we know from where to collect the data, or if we know on which scenario we are going to collect the data, that should be our first step. Okay, so if I'm a data scientist, so what I would do is that first, in any project, I'll try to first understand from where can I get the data, and if I'm not able to get the data, what I will do is I'll try to connect to the business counterparts and understand whether they can help to collect the data. If not, what I could do is that I could actually generate a simple form and then collect the data. Now, Once you collect the data, is that enough? Answer is no. Why? Because the data, whatever you collect, could be some data could be garbage, some data could be, there could be some missing data, or there could be some data that is not up to the mark. So there are quite a lot of instances where the data may not be the way how we need, right? So what do we do in that case? There is only one thing which we could do at that time, that's called data pre-processing. What is the data pre-processing? Once we collect the data, we need to also ensure that the data is in the required form or not. If the data is not in the required form, probably first we need to understand and see how we can collect the data and put in the required form. Next, if we find the data, whatever the data we collected, if it is in the correct format, what next we can do is that we can also ensure that all the things which we are going to do or here, it also exists in the backend. Meaning the data, once it is pre-processed, if there are some junk values, we obviously will try to remove them, okay, or we probably try to input the data. There are quite a lot of techniques which we can employ to clean up the data. But yeah, just to, if I take a simple scenario, if the data is totally junk, I could just drop. I mean, if the data is only junk in one particular column, I could just drop that particular column. If the data is missing in multiple rows, probably I could just see whether that particular row is that so important, and is that column is such important or not. If it is, well, I could just input the data based on the type of data it is, so which we'll cover later. But yeah, so yeah, there are quite a lot of important aspects out there. So most of the time, as a data scientist, what we do is we try to see whether the data is optimum or not. If the data is not optimum, it is always our responsibility to check how we can clean up the data. Okay, so now till now what we have done, we have actually collected data, we have tried to pre-process the data and ensure the data is clean. Now the next step, ideally, is to create a model. Actually, there are quite a lot of things which is going to happen because these are all terms in machine learning, particularly, but it's not typically in data science. If I take a typical data science, if I would have been in the year 1940s or 1950s, as a statistician or mathematician, what I would do, I would rather create a model with a linear algebra, right? So at that time, I mean, there was neither that much data to be analyzed, nor that much complex problems that need to be solved back then. But today we have quite a lot of, I mean, it has advanced quite a lot, number one. And also because of the advent of social media and digital marketing, the game has changed to a whole different level. That is one. And also due to quite a lot of unstructured data could be in the images or videos. So the time to process the data itself has increased. Okay, that is one thing. And the extent to which the data needs to be what's called formatted or processed also has increased. So with a typical linear algebra, we may not be able to create an optimum model right today. Okay, so that is one thing. And also they're all typical machine learning aspect. Like we could even check whether the model what we're trying to select, whether that is optimum or not. There's something called as model selection itself. There is a whole different topic. But once you select the correct corresponding or the required model, what you could do is that you can also ensure whether that model could be even optimized further using, there is something called hyperparameter tuning. So I mean, there are quite a lot of ways we can actually check whether the model which we have selected is the right one or not. Okay, that is one thing. And how do we check? There is something called as evaluation step. So what it does is that it actually evaluates the models, whatever we have selected one by one, or probably we could manually select one by one and then check which model is the optimum for the corresponding data. That is one. Number two, we can also ensure that we can just create something called as assumptions and prove whether that assumptions whatever we had earlier is correct or not. That's called hypothesis testing. That's a whole different topic in machine learning. But that helps us to check whether the model what we have generated is optimum or not, and that could be deployed in the production or not. Meaning, the model whatever we select, ultimately it should solve the purpose or the problem. If it does not solve the purpose or the problem, then model is not going to be helpful, right? So this is about just about the data science life cycle. Okay. So to recap, so we just learned about how this data is going to be helpful, number one. Number two, we also learned about how it is going to be impacting our daily life. And also, we also learned about how we can clean our data and pre-process it. And also learned about the model selections and sorry, model selection and the tuning of your model or evaluating the model at the end, and also see whether the model what we have selected is optimum or not, right? So this is about data science lifecycle. Now let's see about the, now we have learned about the data science lifecycle, but have we learned about the data? No, correct? So first we need to understand the data, so which is crucial in any data science project. So if we do not know whether the data what we have selected is right or not, then it's not going to be useful. Okay. So there are two types of data primarily. One is called qualitative data and the other is called quantitative data. What exactly is it? So qualitative data is such type of data which actually doesn't represent in the numbers or is not in a numerical format. It is representing the type or quality of the data rather than the means the quantifying the data. That if you are able to quantify a data, that will lead to a quantitative data. Means it could be numbers, it could be a floating point integers or floating point decimals or integers, or based on, there are various ways we can actually categorize the data types. That's a different thing. But that if you are able to segregate the data, whether it is going to be numerical or quantitative or qualitative, you half your job is done. Next step which starts over there is that whether you can further classify the qualitative data or not. Meaning, suppose if you are asked to identify the color of a flower, okay, what you would do? Probably you will say the color of a flower is yellow, green, red, or anything, correct? So this is one form of qualifying the data. Okay. Tomorrow, if I ask you to predict the outcome of earthquake occurrence or not, what you can say? You can say whether earthquake occurred or not. Then there's nothing like earth. I don't know, right? I mean, you can give an option that which is very vague, but that's a reality or fact. Either earthquake has occurred or not. There's nothing like don't know. Probably you can say don't know in those places where you say you may not be living or you may not have knowledge whether the earthquake has occurred or not. Then you can say don't know. That's a different thing. So now you know that in the qualitative data also you can actually have multiple ways. Probably, I mean, we'll touch base on each of them in the further slides, but you can subcategorize in qualitative data as well. But in quantitative data, can you subcategorize? Always answer is it depends. Meaning, if I say how many brothers and sisters do you have, probably you will say 1, 2, or none. Would you say I have 1.5 brother or 2.5 sisters? No, right? So there are something called as discrete data and there is something called continuous data. Probably we'll touch base upon that in the next slide, where you will say, okay, this type of data I cannot segregate any further. That's called discrete data. If you say in the case of your height, weight, or temperature, these are the some of type of measurements where you can actually quantify even further. Correct? You can actually say it's 27.5 degrees Celsius or 35.8 degrees Celsius. That's called continuous data because you can segregate even further. Okay, that's about quantitative data. So now, where do we generally use quantitative quantitative data and qualitative data in the real world. If you ask me, I'll say, suppose if somebody gives you a feedback form and if they ask you to rate among 5 out of 5, so what you will do? You will say either 1, 2, 3, 4, or 5. Correct? So this is just you are qualifying whether that feedback was good or not. So in these scenarios, you can go with qualitative data. But suppose the same thing, I'll change a bit. Okay, I would rather giving stars with 1, 2, 3, 4, 5. I'll give a scale of 1, 2, 3, 4, 5. Then the same data could be shifted towards quantitative data, because you can say 1, 2, 3, 4, 5, and it becomes a quantitative discrete data back then. So the data, how you look at the data is what matters. If you think this data could be qualified as a categorical way, there's something called categorical data and continuous data, which you'll touch in based in the further slides. So you will go with that approach, like whether you can give a feedback form with 1, 2, 3 stars and all. If you are giving at a scale, whether this is up to the mark, then you will go with the quantitative data. Okay, so now let's understand about the data analytics. So till now we have learned about data, types of data, and also we learned about where data is going to be used. But without understanding the analytics behind the data, is the data per se helpful? Answer may not be yes or may not be no, because it depends. If the data is very straightforward, you don't need any more analytics. But if the data is a bit complex, then obviously you will need more analytics. What do you mean by data analytics? Data analytics involves the process of inspecting, cleansing, transforming, and modeling of data to find information that is used to make informed decisions. Okay, so we have learned about data, types of data till now. And we have also learned that data in its crude form is not that helpful unless until the data is cleaned, pre-processed, and then fed to the modeling part. Now, there is one more important aspect which I forgot to tell in the earlier, is called transforming data. Why do I say so? Because there could be scenarios where the data in its crude form may not be helpful enough. So in those scenarios, we have to transform the data in such a way that it will be really helpful to us. So if I give you an example, okay, so the data which we have got in the form of the color of a flower, is it helpful if I say the color of a flower is yellow, orange, red, as it is to a model? Is that really helpful to the model? Probably model may understand the patterns from the various images. That's called computer vision. That's a whole different topic. But if you provide a lot of images to the model, and if the model learns the type of color from the image itself, so what happens is that model over the time will be able to understand the patterns and predict the different type of colors provided in the flower. I mean, present in the flower. But that time itself will take long. If there are suppose millions of colors, do you think it's easy for a model to evaluate the whole millions of colors? Answer is no. Right? So rather than that, there is something called as transformation of data. What you do is that we actually create a matrix. That's called not coding. So what we'll do is we will ensure that the data is transformed into a binary format. Means if you give your PC the instructions in binary form, will your PC perform faster? Probably yes, right? Because it understands zeros and ones better. Similarly, if you give a model in the zeros and ones, the model also will be able to understand the data better and give them output faster. So that is what is called transforming. Okay, so that's a whole different topic. But yeah, well, let's dive into the further slides. But probably if I have some time, I'll touch base on that towards the end. Now, modeling also doesn't mean that you always create a machine learning model. Modeling doesn't mean that. What modeling means is that you could use the data which you have generated and generate a report and then present to your stakeholders. That report will become a model in that case. That is one part of thing called descriptive analytics. So probably we'll touch this in the next further slides. Modeling is, I mean, the creating a machine learning model is part of a predictive analytics and not part of a descriptive analytics. Meaning, if you provide a lot of data to a model will learn, and it will also be able to predict up to an extent. But if you ask me, is that the optimum level? Answer may be yes or maybe no, because it depends on the data, number one. Also, it depends on the model how you build, number two, and also the types of features which you select in the model. So there are quite a lot of factors and criteria in order to say whether that is performing up to the mark. So that's a whole different thing. But model per se, can it be used always to predict whether it is coming correctly or not? That prediction will come in the part of your predictive analytics. However, as I told earlier, not everyone may need predictive analytics. Not every business need predictive analytics. Not every circumstances need predictive analytics. It depends on a lot of factors. So let's see what those factors are probably in the next slide. Okay, so in data analytics, as of today, where they are used, data analytics could be used in healthcare, it could be used in travel, it could be used in gaming, or energy management, or many other places, correct? So this data analytics per se is only concerned with the inspecting, cleansing, transforming, and modeling of data. Take any of the industries, could be healthcare, traveling, gaming, energy management, or many others also are there, but you definitely would need descriptive analytics. What do you mean by that? You at least need to know whether the data, based on the data, whether it is performing up to the mark or not, whether the business is able to sustain or not, or whether the business is able to generate profits, or whether the business is going in loss. All those things you can actually measure. That's called metrics. So you can use for data descriptive analytics. That means based on your past data, you can at least you'll be at least able to know whether your business is heading towards. Okay. So now another important thing would be analysis of the weather data and pest data to verify whether there is a high correlation of certain types of fungus with the humidity level, which is certain point. So this is yeah, I mean, here you'll also have a past data, because probably the weather data could not be just of this month. Probably similar weather condition could be there last year, or probably even year before. So if you have a past data, then use that past data to find a pattern. That's called correlation in this case, but to find a pattern to check whether that there is a type of fungus in the humidity when the humidity level reaches certain part or not. If there is, what you can do is that you can actually use predictive analytics to check whether there is any fungus in that or not, and try to procure the crops in such a way that either the time or the date or the conditions is not the same as what it was earlier. Okay, so this automatically ensures that your crops are optimum and they do not stale. Okay, that is one thing. Now, future climate projections for the following case is almost similar to the above point. So I'm not just going to I'm going to just go to the next slide, but you can do almost data analytics on almost any business case. Okay, because data analytics doesn't just involve predictive analytics; it also involves descriptive analytics, which is analyzing the past data, and also there is something called diagnostic analytics, which we'll see in the further videos. Yeah, this is the point. Data analytics has 4 different types of further segments. One is called descriptive analytics, another is called diagnostic analytics, another is called predictive analytics, and the last one is called prescriptive analytics. So now, what does that mean? So actually, this is something called as Gartner's what you call the quadrant. So what it means in the hindsight is that, okay, so it starts with identifying the past data. The past data will come in the descriptive analytics part, meaning you know what happened earlier, right? So that if you are able to track, either you collect the data manually or you use some application to track the data, probably in your database or any other Excel sheets or any other places. At least if you have data, at least you can use that data to do some analytics, means to measure whether it is coming properly or not. That is descriptive analytics. Now, what is diagnostic analytics? That's actually also called as an insight. What it means is that it tells you based on the past data which you used in the which you gathered in the descriptive analytics phase, you can also take you can also understand why it happened in the first place. Means if I take an example, if I see that this last month there are quite a lot of mangoes which got rotten. Why? I mean, you found data saying that a lot of mangoes were rotten. Okay, in the month of May, suppose. Now, if I ask you, you just got the data, is it going to be really helpful unless until you do some analysis on it? Answer is no, because it is not, the data per se is not going to help any case unless until you do some analysis on it. Okay, means you can say, why did the mangoes rot in the first place? Okay, I saw out of 100 mangoes, 90 mangoes were rotten, only 10 mangoes were good. So you should also ensure why did it rot in the first place. That is called as diagnostic analytics. You try to understand why it happened, not just what has happened. Okay, that is one. Number two. Number three, predictive analytics. Suppose you got the past data that the last year or the previous year, you see that in the month of June, the mangoes, if they are not plugged out, probably they would get rotten. Why? That you will identify through diagnostic analysis, saying that okay, by June it may start to rain and probably your mangoes may get rotten. However, is that enough to predict whether this year in the month of June, whether you the same time, if you are not going to pluck the mangoes, whether it will get rotten? If you have the past data and if you have a model to predict whether it is going to rain in the month of June, you are probably will be more informed, correct? That is what is predictive analytics. You create a model based on the past data. If you are having, so in some scenarios you will not have the past data also, that's a different thing, but most of the time you have the past data, use the past data to create a model to predict whether the similar business case can happen in the future. Okay, so if it happens in the future, how are you going to handle it? So you can take a decision even beforehand, right? Probably you'll pluck your mango seed faster if you know that in the month of June it's going to rain, right? So that is predictive analytics. The prescriptive analytics is a bit more advanced. Why do I say so? Because in the prescriptive analytics is one step ahead to predictive analytics. it will it will also say back to you based on the past data and based on the previous model and based on previous trainings of the model. It tries to understand and suggest to you what you need to take rather than you take a decision. It suggests you. It is like a recommendation system which you see in the daily days as of today, like probably Netflix and in many other places, right? That is prescriptive analytics. It tells you or it educates you based on the past data which it has and based on predictions which you had done earlier, based on the models which you have created. Why don't you take this step so that you are safe? It prescribes you. Okay, that's one step ahead of your predictive analytics. Most of the startups and the very advanced enterprises are now starting to use prescriptive analytics. Ola is a good example, or Uber is a good example, and Amazon is a very good example. There are quite a lot of enterprises which are doing it. So what happens in this one is that in the prescriptive analytics, if the system always suggests, that doesn't mean that system is always right. Okay, in some scenarios, what happens? A system based on the past data, it would have predicted, and based on the models which it had trained earlier, it would have suggested it. there could be some scenarios. It's like your Netflix recommendations, right? Not all movies what it suggests probably you would be interested of. In some of the movies probably would not be that worthy enough, right? So it at the end of the day, based on each interaction which you have with the system, if it trains again itself and then comes up with an optimum model and it betters its own accuracy of predicting and prescribing you the best results for the next time whenever you try to interact with it, that is where the future is heading towards, right? So based on the past data which it had created model, it had done some training of the model, and based on your interaction with the model, it learns in itself and tries to optimize its model and give better recommendations or prescriptions for you to take a decision. That is where prescriptive analytics is headed to, and that is where most of the future business aspect is going to be. Now, if you ask me, does every business needs a prescriptive analytics? Answer may be yes. Answer may be no. It depends. It depends on data. It depends on business scenario, use case, and many other things. If you ask me to predict whether what you call mangoes could be plucked or not before rainy season, I would say you do not need a prescriptive. You do not need a model to suggest you. It is half what is called as self-explanatory. Half it is based on common science. Half it is based on their past data and their predictions as well. But you do not need to wait for your model to prescribe you or suggest you whether you have to pick it or not, right? Rather, you use the existing model or you use the existing data to arrive at insights. So not all business scenarios you may need prescriptive analytics. That's having said that, there is another important point which I forgot to explain earlier. So yes, data science, as I said earlier, is the genesis of AI. So is the AI alone enough? Answer as of today, maybe not. Probably if you had asked the same question 50, 60 years ago, I would have said yes. But as of today, no. Why? Data itself has blown up so much. Number one, models themselves have become so robust. Means every day based on business scenario, businesses also have got dynamic very much. I mean, compared to the earlier times, today businesses are more dynamic than the earlier ones, right? So even the business scenarios, use cases, even the models that you predict as of today may become obsolete tomorrow. There's no guarantee saying that okay, the previous models would always be performing better even going further. No, answer is no. There could be some scenarios where the models that you build today may get obsolete. Now how to address such a scenario? For exactly that, the AI itself has been subcategorized into multiple places. That is called machine learning, which is itself is a subset of artificial intelligence. And in machine learning, there is one more thing called deep learning, which is a subset of machine learning itself. Meaning, in the machine learning phase, you are just going to predict, you are just going to build a model and use it for predictions. While in the deep learning phase, if suppose if a model is giving a good result, optimum result, but if you're trying to see whether you can get a better or higher result than the already generated model, you can go to deep learning and verify whether you can get a better accuracy or not. Why? Because in deep learning, ultimately, it's like it mimics like a human brain. It's an artificial neural network under the because there are a lot of nodes. From the one output of one node could be fed to the input of another node, so that the accuracy could be improved. And similarly, there will be mesh of nodes, and you will be able to get a better output. So deep learning is an area where you can actually get an optimum result. But having said that, it also there are pros and cons of each of the thing, right? Okay. Uh, do you need always a deep learning model in all the scenarios? Answer may be yes, also may be no. It depends on data, number one, because deep learning definitely needs model humongous amount of data. If you have big data, you can actually go with deep learning model. If you do not have enough data, then it is better to go with a machine learning model, or it could be, I mean, if there's very simple scenario, you can go with the descriptive analytics and diagnostic analytics itself. You don't need to go to the predictive analytics like machine learning. But if the data is optimum, and if you want to, if your business is comprises of predicting some amount of data or insights out of it, then you go with the machine learning. But if you have a humongous data, and if you are aware that the machine learning model which you had built earlier could be even optimized further, then you go with deep learning model, because there it actually tries to extract humongous amount of data and feeds to each of the nodes. And each of the nodes ultimately will give a better predictions in when it goes further and further and further. At the end of the day, you're going to get a better result, number one. And number two, it is going to withstand up to even if there is a slight business uncertainties, it will still be able to withstand that predictions. But it's not the same case in machine learning, because machine learning just you give one input and you're trying to predict a model and then you get an output. But in deep learning, since there are multiple nodes, even if there are chances that one node may miss one particular attribute, the other node may pick it, right? And probably similar subsequent nodes can be optimized even further. So chances of business resilience in deep learning is lesser. Having said that, most of the companies are evaluating whether they can go with deep learning model, because as of today, to be honest, all and big enterprises at least have huge data. They will be able to proceed with the deep learning models for sure. But it's just the small and medium enterprises which do not have huge data, they are finding difficult to proceed with deep learning models. Okay, but having said that, is the deep learning always required? Answer may be yes, answer may be no. It depends on business use case as well. So if it is a simple use cases, you may not need deep learning model. If it is a very complex use case, or probably if you need a prescriptive analytics type of application, then you will go with the deep learning model. Now, okay, we have quite a lot of things to cover, but let's first understand what is a strong AI versus weak AI. In AI also, this probably I should have taken a bit earlier, this section, because this was quite an important topic, which I think I missed somehow. Strong AI and weak AI. So what, I mean, if we are using Siri, if we are using Amazon Alexa or Echo, where do these fall? Do they fall in strong AI or do they fall in weak AI? They fall in weak AI. Why? Because you ask something to the Echo or your Alexa and it responds back accordingly, right? So it is programmed to do one particular set of operations, and hence it is called weak AI. Means it cannot identify on its own, or it cannot learn or train on its own and to optimize its own accuracy, or optimize its own results. So that is the limitation of a weak AI. But having said that, almost every type of AI application as of today is weak AI, except for some of them, like some of the recent research which is happening in Google DeepMind and the GPT-3. Those things and all are still in the research. Some of the places people are using it, I'm not denying. But generally, if I say, most of the AI applications which exist today, probably even chatbot, it could be your predictive models, or it could be your deep learning models, all of these come under weak AI category. Now, if you ask me, so all these all are weak AI, what is strong AI? So strong AI are those AI models which actually uh, are able to predict and learn on their own. Okay, from the past data or past, like there's something called as reinforcement learning, which is not a strong AI to be per se, but it actually somewhere lies in between a strong AI and weak AI. What it does is that it actually gets the past data, okay, and it tries to do predictions, and based on the feedback which you give to it, probably if the predicted output, if it is right, and if you say to the system that it was right what you predicted earlier, then it learns from the past what you call output. What the output what you give to it will be given as an input back to the model. Means the output what you give is like whether it is correct or not. So that becomes available. So there are quite a lot of things which is going to be there in it. But just to give background, it actually, if I say, it's like a child how it learns, right? If you a child per se will not have a lot of knowledge when it is born, but as the time progresses, you give feedback to the child. You say, okay, do not do this or do this. Based on what you say and based on the feedback what you give, child learns, and then it tries to optimize its operations. And that is what is happening in the reinforcement learning also. Whenever you give a positive feedback to the system or the model, it gives a higher point, like positive point, and it says that okay, it is a good scenario. When you give a negative feedback to the system, it learns and says that okay, next time probably I should not try this, and it gives a negative point of view. So it learns from its mistakes, learns, relearns, and that is how it actually improves its accuracy. The model itself improves its accuracy, and that is happening in the reinforcement learning. And the it is, I'm not saying that reinforcement learning or this is also called semi-supervised learning, but that is not something which is uh, that is not something which I will say it will some way lie in between strong AI and weak AI. It's not a completely strong AI neither. It is not completely weak AI, because it is something which is still in the research, and in some of the areas it is not. It is already being used. I'm not denying it, but if people now, I mean, most of the universities and enterprises are moving towards understanding, can we create a model which is generalized or not? If we can create a generalized type of model, probably we should go towards that. Why? Because if the same model could be used in multiple business cases, and if it could be used in multiple business cases, that also means that the model could be so resilient that today if you get that model trained for probably understanding the chess game, tomorrow the same model could even learn Rubik's cube, because that's called artificial general intelligence, AGI is called. So means the AI becomes so strong that it is independent of the business case and use cases. Even you give tomorrow any other use case, based on the past learning which it had in the previous business case, it tries to optimize its own accuracy. That is strong AI. In strong AI also there are multiple things like artificial general intelligence, artificial super intelligence, and so we'll not go so deep. But just to give a background, general intelligence is where you can use it in multiple places. Super intelligence is where as of today it doesn't even exist, and probably it may not even exist also. That's what I feel. Meaning like it the AI tries to learn in its own, and probably it could reproduce on its own as well. Meaning it could create its own new version of AI and try to optimize its own accuracy every time. That could be a whole different debate, because that could lead to quite a lot of inconsistencies, ethics, and also it could lead to some catastrophe if it is not handled properly. So we will not touch base upon a lot of topics on artificial super intelligence. Recently, I had actually created an article, and actually I sent across to many of my followers. So if you want, I can just provide you a link of that in the description of this video. Let's move on to the other important topic, that is big data. What is a big data? Big data is a data that is of very large volume. Why do I say so? Because if you have a small set of data, probably greater than 100 MB to 1 TB or something, you can actually use descriptive analytics or diagnostic analytics to arrive at a result. It's like Excel sheet having all the data, and if you're trying to analyze the Excel sheet, you can actually do a lot of analysis on your basic Excel sheet itself. You don't need a lot of programming for that, right? So, however, now if you are asked to say, can you do the similar type of data analysis in a data which is almost like 1 petabyte volume? Can you do that? Answer may be yes, or answer may be no. Answer is no, because you cannot do a descriptive analytics or diagnostic analytics on a data of 1 petabyte, right? You need to have a good, strong resilience towards a model that needs to be created. Okay, so imagine the data, if it crosses 1 petabyte, where it will go? I mean, you can have a cloud system to store all your data, or you can store all your data in a what is called a NoSQL database, where it can actually extend as the data goes by, or you can even store it in your relational database, so where you can actually ensure that you have a lot of server space or storage space, and then store the data. You can do many things, that's a different thing. But having said that, big data is not a single type. What do you mean by that? That is, it's not a structured format. It could be in unstructured format, meaning if the data is present in an Excel sheet or in rows and columns, it could be like what I can say. You can actually treat that data as a structured data. You know, okay, the data will be in the rows and column format only. However, if I ask you to do some analysis on the data which is probably in an image format or in a video format, would you be able to do descriptive analytics or dense analytics on that? Answer will be yes, and answer will be no. Because if the data, if you have only one image, probably you will be able to do. But if there are multiple images, probably 1 petabyte of data of probably video, will you be able to do that? Answer is no. So big data is data that is being generated at a much faster rate than the data in the past, and all kinds of sources, including social media, are contributing to it. So if you ask me back 20 to 30 years ago, was the big data present? I'll say no. So if you ask me 20 years down now, down the lane, whether big data is going to be the huge, I'll say yes, because as we grow by, our social media is just going to explode, and also our data ability to store might also get into a bottleneck. So there could be a day when big data could lead to a catastrophe as well if it is not handled properly. Okay, so if you ask me, so how is it going to have an impact on AI? So suppose if our existing models are able to use the big data and predict properly, that's well and good. But if the same thing happens at 20 to 30 years down the lane, when the big data is so huge, and if our models are not optimized up to that level, the models may fail because the data is so huge, right? So it is a concern as of today that I mean, as of today there is no concern, but it will be a concern in the future, that if the big data is not controlled or if the big data is not handled properly, our AI models may fail. Okay, so that is one thing. And big data is data that requires newer ways to store, process, analyze, visualize, and interpret. Why do I say so? As I said earlier, as of today, we know that image and videos could be termed in big data because they generated quite a lot of bandwidth, right? However, we don't know. Will these be the only ways to generate data in the future? We may not know, right? In the future, probably there will be something which could be very new that could lead the even higher amount of data. Then how do we manage? Right? The data has to be streamlined ultimately, and then only need to be fed to a AI model. If not, there are chances that AI models may fail. Okay, so this is all about big data. So probably what I would do is that this was a very big or brief overview about data science. We learned about data science lifecycle. We also learned about the types of data, learned about data analytics. We also learned about the types of data analytics. We learned about the difference between AI, machine learning, and deep learning. We also learned about the strong AI versus weak AI. We also learned about the big data and how it is going to impact us, particularly in the field of AI. Now, Let's come back to our actual topic, that was AI, right? So in the AI, so some of the topics I think we would have already covered, but the ones which are not covered, I'll just quickly touch base on. Intelligence which is demonstrated with machines is called AI. That's the simplest definition which I could find. Why? Ultimately, if a machine is able to mimic a human intelligence, the human intelligence is natural intelligence, we can say. So, what could the machine intelligence be? Obviously, it is artificial intelligence, right? So that is how I term. Then, it is the simulation of natural intelligence in machines that are programmed to learn and mimic the actions of humans. If the machines are able to learn, I repeat, if the machines are able to learn on its own, that means they are at least able to understand that humans also learn, and based on the way humans learn, if they're also able to, like the way how I said about reinforcement learning, if based on the feedback which it gets, if it tries to optimize itself, then that will lead to a better accuracy. Okay, so we can generate a good amount of model in that case. Now, these machines are able to learn with experience and perform human-like tasks. What do I mean by that? Suppose tomorrow, if the machines are will give something like if the machines can do the similar task what humans are doing, so do you think machines could replace humans? Probably yes, probably no. If it is a repetitive task, or the ones which you know what would be the output if you give this type of input, then probably you can say machine could replace it. But if the task is such a way that it has to have something like emotional intelligence, uh, or any other type of psychological things, so which a machine may not understand, then probably it may not, right? So uh, as of today, this is still a research and naive topic, where people are trying to see whether machines could be fed with emotional intelligence and all. So it's still a research topic, but probably someday it could be beat even the human in intelligence, emotional intelligence as well. Who knows? Now, how do we measure if AI is acting like a human? There are quite a lot of ways to measure it. One could be something called as testing or evaluation step, which I shown in the earlier data science life cycle. So if you see that the model is predicting the way how you expect it and give back the feedback to the model, which we saw in the reinforcement learning. So that way you can actually measure AI, number one, and also you can ensure that AI is optimized. Okay, whenever AI gets optimized and learns from the past mistakes, that is when it acts like a human, right? Now, what things AI may not be able to do? Probably reproducing itself, because that is only human who can do it. So but except that, almost every other aspect, AI might be able to do it. I'm not denying it. uh, Probably AI may not be able to eat, or probably AI may not be able to do those activities what a human does, but AI definitely will be able to do those activities what a human thinks, right? As of today, it is still a research topic. Like emotional intelligence are still being researched upon various universities and enterprises, but that could also be a huge change which may come in the future. Now, what is this cognitive modeling approach? Cognitive modeling approach is where you would actually create a model in such a way that it understands the human abilities. That is cognitive intelligence. So that's a whole different topic, like cognitive modeling, how we can how we can use the cognitive modeling things and all. What we'll do is that we'll see each of the topic in much detail as we go back, because some of the topics are going to be re-referenced in the further slides, I'm pretty sure. So there I'll touch base on them, right? So that could include the loss of thought approach, could be rational agent approach, or could be even how the AI works. Okay, AI works is a generic topic. I'll not say much on that, about that, but at least let's touch base on the other aspects. Now, Okay, different types of AI. Some of the types of AI which I was saying earlier is strong AI versus weak AI, which we already discussed. And the others are like artificial narrow intelligence, artificial general intelligence, and artificial super intelligence. This is what I was saying. Artificial narrow intelligence is something which is very basic thing. Like you ask it and it responds back. That is artificial narrow intelligence. As of today, most of the systems which are falling under weak AI are all artificial narrow intelligence. To be honest, even including the deep learning networks. But yeah, somewhere reinforcement learning is somewhere in between artificial narrow intelligence and heading towards artificial general intelligence, but it is nowhere close to it. Artificial general intelligence, on the other hand, I'll not say it is also strong AI, but it is somewhere in between strong AI and weak AI. Why I say because uh, it's like Google's DeepMind, which I was saying about GPT-3 algorithm, generative pre-processor text. So what it does is that there is a training algorithm which has been created by a DeepMind, sorry, it's from OpenAI. So what it does is that it actually trains itself. I mean, the model has been fed so much amount of data, it tries to learn on its own with a lot of data which is being fed, and then comes up with the optimum model, right? That is artificial general intelligence. That is where the systems are trying to understand based on the past data and optimizes its own accuracy. And the beauty of this one is that you can use the similar model, and if you find a similar business case somewhere else, you can use the same model over there and try to use the model and try to predict the accuracy, try to predict the results, right? So artificial general intelligence is going in such a way that you use the existing model, or it's like reusing the existing model in multiple business cases. Now, what is artificial super intelligence? Artificial super intelligence is one step even ahead of artificial general intelligence, where it tries to learn on its own. Okay, it tries to evaluate on its own. In the artificial general intelligence, we evaluate, but in the artificial super intelligence, system evaluates on its own, and it tries to optimize its own accuracy or its own results. Okay, when it tries to optimize its own result, that is when we need to be also be equally aware of it. Means it there could be some scenario where it could surpass human intelligence, and if it is put in a constructive manner, it is obviously good for a society. But if it is not put in a constructive manner, probably it could destroy the humankind altogether. So it is definitely a concern. It is a point of concern, no doubt. But having said that, we are nowhere close to it, and I'm pretty sure it is not going to be that easy to attain artificial super intelligence. And I know that a lot of sci-fi movies, particularly in Hollywood, they are mostly concerned with artificial super intelligence. They show as if that it is going to be someday it will catastrophe our daily life. So probably I don't believe that it will happen anytime unless we be so negligent and we do not follow our own ethics and moral values. Then until that happens, so artificial super intelligence is nowhere near. So we are safe from that. Having said that, okay, let's understand the significance of AI and why. What is the purpose of AI? What are advantages of AI? We learned about AI and all. We learned about the purpose of AI also with the different aspects, probably in the whether it could be for machine learning or deep learning or many other purposes also we have learned. What are the advantages of AI? Now, that's what I said earlier. In the past, 50, 60 years ago, your business case was not that dynamic. Okay, but today business cases are dynamic. Business are evolving at a faster speed than what it was earlier. Now, is it enough to sustain the market? Answer is no, because unless until you take unfair advantage of with the various data points which may arise with social media or digital marketing or many other data points, if you're trying to arrive at it and take the benefit out of it to create AI models, probably your competitors may oversmart you if you do not do that. So rather than you allowing your competitors to take advantage, why don't you take it? That is where advantage of AI comes into picture. You take all your data points, not just from within your business, but also from across, probably social media or from your Google trends or any other places. Take those into consideration and then formulate a proper business approach, right? So that doesn't mean that there will always be advantage of AI. There are quite a lot of advantage of AI. This is just one such aspect I said. Probably it could be used in your recommendation systems, could be used in your cognitive intelligence systems, could be used in your image processing systems, could be used in your language extraction systems or text extraction systems, or it could be used in the automation systems, and a lot of places it could be used, no doubt. But are there always advantages of a answer? Maybe yes, answer no, because there could be disadvantages also. What do you mean by disadvantages? Disadvantages includes so tomorrow, if you ask me like are all AI is helpful for all the mankind? Answer maybe no. Because if it is a very small data, and if you're able to predict with a small linear equation itself, why do you want to even go with predicting or creating a model and then predicting on top of it, right? So it is our responsibility to see the data, validate the data, validate the business case, validate whether that model creation is really important or not, and based on that we have to select the corresponding AI. Right? That is number one. Number two, AI, if it goes towards artificial super intelligence, which I highly believe it could be likely, but if it goes, then probably it could lead to a catastrophe as well, right? So there are advantages. Wherever there are advantages, obviously there will be some disadvantages, but it is our responsibility as a moral citizen of, so how we or data citizen, how we use the data properly. It's a balancing act. That's what I tried to say. It's a balancing act between your advantage and disadvantage, and way in such a way that you take advantage of AI higher and leave the disadvantage to the buried. Now, having said that, where and all AI could be used? AI could be used in various places. It could be used in healthcare, it could be used in e-commerce, it could be used in human resources, HR, or it could be used in assembly lines in production, it could be used in customer service in your typical sales department or customer service department, or it could be used in packaging, it could be used in logistics, I mean to say. So there are quite a lot of places where AI could be used. Now, probably we'll take a separate session on the application of AI for business, because that itself is a very vast topic. Okay, so what we'll do, we'll take a short break for a minute and then proceed with our next session. Now, all this time we learned about the artificial intelligence, we learned about the genesis of artificial intelligence, we learned where artificial intelligence could be used. But what we didn't learn is the real-time applications of artificial intelligence. In reality, artificial intelligence is already being used in multiple places, where it is used in the retail, it could be used in healthcare, banking, infrastructure, trade and logistics, media and entertainment, education, manufacturing, energy and utilities, and also in public sector. Now, if you ask me, in each of the places, if it is used, then how are we going to use it? So, in the retail space, it could be artificial intelligence is already being used in, if suppose there is something called Google Lens, right? So, if you are going to shopping across your retail stores in your vicinity, you can take your Google Lens and ensure that and check whether that if suppose you are going for a garment store like the one which we see over here, you take a snap of that and see whether you are able to find similar product anywhere in the online or any other places. It is available for a better price or could be for a better size. Okay, so you would have gone to a store, you like the product, but you do not find the exact size what to fit. In that case, you can also ensure this. You take a snap and try to get other piece with your size, right? So that helps out there. But having said that, now some of the shops are intelligent enough and they do not generally allow you to take a snap. Okay, there are some shops which allow, but there are many shops which do not allow as well, because ultimately it's not going to help them in the long run, right? So as a consumer, it's a win-win situation for a consumer, but is it a win-win situation for a business? Answer is yes or no, because if the business would not have had that particular what do you call size, and if suppose if the business has another shop or another branch in another location, and what instead of customer taking a snap, the business itself can take the snap and check whether a similar size exists in the other shop or not. So in those scenarios, it is a win-win situation for business as well as consumer. But if you say that if it doesn't have any branch, or if you think that as a business owner, if you're going to lose your revenue, rather than that, you will say no, I probably will not allow you to take a snap. Rather, you say, right? So there are some advantages, there are some disadvantages. Wherever there are advantages, there will be disadvantages, no doubt. That is one for retail. And this is just one thing. If you take about the online retail, right? Online retail, almost e-retail or e-commerce, what I can say, almost every company is using artificial intelligence. Take, for example, Amazon, or take, for example, any other what do you call the e-commerce site. Could be your eBay, or could be your even actually, if you think in a different way, any groceries, online groceries or online dairy, all these things actually come under retail itself, right? So every other business which is in the retail should and must use AI. Why? Why do I say so? Because there are huge data points which gets generated with retail. Okay, some of them may have less data, like a garment store. If it is in a good season, probably it will have a lot of data. But if it is an off season, means probably they may not have enough data. That's a different thing. So, but there are other areas of retail where the seasonality doesn't matter, and you will have a continuous data points every now and then. In those segments, definitely AI should be used. Definitely AI should be used, because you can also ensure that, though you know as a common sense that there is no seasonality, but if you predict something could happen because of the outcomes, or because of some global environment or inflation or any other thing, external factors could impact your basic understanding. And if based on the past data, if the system learns, okay, in the month of June, when it is going to start raining, your mangoes, I mean, the price of mangoes will fall. So what you can take as a shopkeeper, you can take a decision to lower the or increase the discount on the mangoes, such that it at least sells out. I mean, your inventory is reduced. So there are quite a lot of use cases of AI in retail as well. So like there could be like that's what I said. One is inventory stock out. That could be one issue, like how to overcome the inventory stock out issue. And also there could be scenarios where predicting the customer demand during a peak season, or predicting the customer demand in the off peak season. There are or customer churn, a lot of areas where AI could be used in retail. Now, let's learn about the healthcare. In healthcare, also AI could be used, and already being used in multiple places, particularly in the current situation. AI is the life-saving thing for the healthcare, particularly. So, if suppose you are trying to predict whether a person is having cancer or not. So if without AI, what used to happen is that you physically go to a diagnosis center, get it scanned, and the diagnostic person would physically verify manually or algorithmically, and then he would try to results. Now, if with the AI, it's just a matter of scanning your entire body or based on the however the requirement may be, then the data point, if it is fed to an AI algorithm based on the past data which is being fed with it, which it had, so it could try to predict whether you have cancer or not, right? That is one particular scenario in healthcare. Now, is that the only way, only place where AI could be used? No. Healthcare doesn't mean that it is always in the health segment per se. It could be in your fitness. It could be in your medicines. It could be in your what is called the mental peace or anything like that. Personality development. Personality development per se will not come in healthcare, but at least mental stiffness or mental peace, all these things will come under healthcare itself. So you can ensure that okay, you have taken a data. Suppose you have a data of that you have enrolled into a fitness club. Okay, so you're going to hit a gym every day, and the system, if we know that you are hitting a gym every day, and if you are not hit a gym for the past couple of months, probably we can come up as an AI expert. I can arrive at insights that since you have not hit the gym for the past 2 months, probably now it's a better time for me to market, or probably it's a better time to offer you some health remedies. It could be assisted what do you call virtual event of yoga, or could be fitness sessions, virtual fitness sessions. Okay, that is one thing. And also probably you could be provided with some health supplements, or it could be provided with nutritional food. So all these things will come usually on the healthcare segment. Okay, so probably with the help of AI we can predict whether you would be interested to use a subs, or whether you would be interested to use a carbs. So all those things we can actually predict with the healthcare AI. Now, moving on to the next one, that is nothing about banking and finance. In the banking and finance, also AI could be used. How and where? AI could be used in, suppose if you are trying to predict whether the what you call credit card transaction is fraudulent or not. In those scenarios, you can use AI. And also, if you want to predict whether you are eligible for a loan or not, so there also you can use AI. Particularly machine learning algorithms, you can actually, there is something called binary search. So I mean, you can create a algorithm, probably two-class logistic regression algorithm, and then ensure whether you are going to predict whether we can predict whether your loan will be eligible for, whether your application for loan is eligible or not. Okay, so there are a lot of ways we can actually predict. That's a different thing, but that doesn't mean that AI is just for predictions alone. So in banking and finance, particularly, a lot of charts and reports are being uh, extracted on a regular basis, and there are quite a lot of compliances following, right? So banking and finance is one area where AI is going to significantly have a profound impact, and I'm pretty sure that is going to be there not just today but also in the future. Uh, because banking and finance, as of today, we just know what we see in the daily life. There could be in future, there could be a scenario where banking may happen in your home at your desk, right? There could be a scenario where you'll be able to draw money sitting at your home. You may be wondering how it's possible. As of today, it is not possible. Okay, you cannot draw cash sitting at your home, right? You can only do an online transaction, but there could be some scenario in the future. You can actually extract, or you can actually what do you call it, get a cash sitting at home, probably just with a 3D printers. Okay, you can have a 3D printer which is connected to your laptop or which you're connected to your device, and you just press a button on the 3D printer and get what is called as, if it is regulated by an authority, centralized authority, probably they have some of their own images. I mean, that's called 3D images, which you can actually feed to the 3D printers and print the what cache right at your home. That could be a scenario, right? But having said that, if you do it fraudulently, you could even end up in a lawsuit. So it's a balanced thing, and it is how we take AI forward. Like if we are taking AI responsibly and ethically, then it's well and good. But if we are not, probably then it could lead to catastrophe as well. That is about banking and finance, and I'm pretty sure banking and finance is one area where we have not yet fully explored, and that is it's an ongoing process. Though there are quite a lot of enterprises which are already embracing AI, but that doesn't mean that it's the end of it, and I'm pretty sure that it's not going to be finished at least a couple of more years. Okay, and it's a research which is going on, and it will continue to go on for sure. The next one is in infrastructure, particularly in the field of cloud infrastructure, which I'm more concerned with, because as of today, we have humongous data, which I said about big data. The data cannot be stored in a typical laptop or typical machine wherever you have a limited amount of data memory. So rather than that, why don't you create clusters or nodes of clusters or nodes of machines to store your data, right? So you can actually hire or you can enroll 5 to 6 data centers and store the data in each of them, such that the data is uniformly distributed across each of the data center. This uh, when you take in totality, you can actually arrive insights out of it. How? If you take data from one data center, and if you take data from the other data center, and if the data is matched, or if the data doesn't match based on the scenario or based on the data present over there, it could be even replicated data, it could be a non unreplicated data. You can actually arrive at relations between them. If you're able to do something called correlation among the data, then what you can do is you can actually arrive at results whether this data is enough to create an AI model or not. Most of the cloud operating systems or cloud environments are having something called as resource sharing. Resource sharing is in the sense you can actually pool the particular type of resources in the cloud, and from the cloud you can actually extract the data, and those pooled resources would have extracted data, and that data can be fed to AI system. And in this case, what happens is the data is being now fed from multiple places from the pooled resources, and the data sometimes it could be what is called related, sometimes it could be unrelated. Based on that, if you when you're trying to arrive at insights, obviously it will be more what is called helpful. That data would be more helpful, and you can actually ensure that if the data centers are providing you enough data, you can also ensure that the data centers are never failed, because you can ensure there is a failover safety which is being enhanced in the cloud infrastructure systems. So that is one area which I see where it will go ahead. And recently, I remember I think Google or some other company also got their systems hacked. So how to handle such a scenario? I mean, even after having such high predictions or detection of the infrastructure, fraudulent transaction or fraudulent operation in the infrastructure, still there are companies which actually failed in this area. Okay, and every time business is dynamic, business scenarios will be dynamic. Business, when it gets so much dynamic, obviously an AI application will be helpful to be resilient with such scenarios. This is about infrastructure. Now, let's learn about trade and logistics. In the trade and logistics, particularly AI is used in the field of transportation. Why do I say transportation? Because as of today, like enterprises like Amazon, Amazon uses AI. Amazon, particularly, it's a delivery. That's called Amazon Parcel Service or something like that. So Amazon Delivery Services, I guess. Yeah. So what they do is they actually use AI to find the optimal route between the source to the destination, and this in the long run actually helps the company save quite a lot of amount and enhance their efficiencies, right? So suppose if they if it would have been 20 years back, if you are asked to bring what is called an oxygen concentrator from somewhere Russia or some European country, what you would do, rather you would take a ship and get all oxygen concentrators migrated, right, or transported, right? But today, uh, now based on the AI, if you, I mean, you do not need AI per se, but if you have AI for it, what you can ensure that instead of that same ship traveling from across Atlantic Ocean or Pacific Ocean, you can ensure that it travels an optimum distance and reach the same concentrators could reach your place earlier. That is number one. And also, you can use AI to see what other transportation modes are possible. Probably you can use a private jet, or probably you can use a passenger jet or a cargo jet. Based on the scenarios, you can actually enhance the you can reduce the time of delivery, number one, and also increase the profitability of the business. So that you can ensure with AI. In the past, you could not have got such an amazing insights that you have today. Now, let's learn about the media and entertainment. To be honest, media and entertainment itself is a vast topic, and I don't think it can cover in 1 hour. So, like Netflix recommendations, sponsored things. So, and also it could be a news category, like recommendations. Okay, like if suppose Google News or any other news, if it learns that you are more interested in sports, probably it may provide more valuable content in sports, and also it could design or tailor the ads more suited to sports like gym equipment for you, rather than giving a headphone for you, because you are not much based on the data which it has. You may not be more geeky, but you are more a fitness kind of person. So it is more good if you are given a whey protein or dumbbells or any other gym equipments, you might be more interested towards it, right? So this is one aspect of media and entertainment with the ad targeting. And the other aspect of media and entertainment where AI is reforming as of today is the recommendations, which I said earlier. Probably, if you based on your past history, if you have liked one type of serial or one type of video, probably you may like similar type of other video if you are given a chance. You may even be more interested to learn that particular type of video, or based on the what is called more the data it has, more the recommendations it can give, and more recommendations it can give, more the business it will have. So this is where media and entertainment is heading towards. Okay, and typically there are a lot of OTT platforms as of today, and OTT platforms mostly are like what you call, they collect the data from the user, and they collect the data in the real time, and also do analytics on top of it. The recommendation system which you see particularly in Netflix, it happens in real time. And also suppose you are newly joined into a Netflix system, okay, still you'll be able to find some of the recommendations. How? Based on the data which it has from the multiple sources, or it could be based on your own form which you have entered when you are creating a new account, or could be from the other social media channels, could be from Facebook or anything else, and also it could be from the newsletters which you might have opted earlier, right? There are multiple places from where the data points could come, and those helps Netflix to recommend you, even being a new user, the types of movies that you would be interested in. Okay, so that is one particular aspect of media and entertainment.
And there are a lot of other use cases of media intent which I'll not touch base, but yeah, it will take quite a lot of time because I'm pretty sure media and entertainment is one such industry which is being embracing AI from quite some time, and I'm pretty sure it is going to be continuing in the future as well. So that's a very good area to be with. Okay, so this is about media and entertainment. So now let's learn about the educational field. AI is transforming even education. If you have noticed, so if you would have seen this video, probably you would have seen because uh, we optimize this video to appear in the search results, probably using our search engine optimization techniques. We use even AI techniques for SEO. So that is when actually you will be able to see this video in top. So, and also educational services can also use AI for revolutionizing something like, particularly in the current scenario when people are mostly hooked up to their devices from their, probably their home or office or anywhere else, to learn different aspects. So what you can ensure is that you can take the data point based on their location, or based or if there is any live sessions. So based on the live data which it has, it could predict, okay, what type of sessions are really interesting and what types of not. So based on that, it could recommend the similar type of courses which you may like. Number one. Number two, it could also recommend similar type of avenues or tools which you may like, because education is not just about the way how you do it, also about the practices or the exercises what you do as well. And suppose if you're part of any course or higher education or anything else where you have written an exam or a practice test, so you might be interested to know whether it was positive or negative or anything, right? So in those scenarios also you can use AI, whereby AI could do, or AI could prescribe whether it is whether you are going in the right direction or not. Okay, that is about education, and that is one aspect. And the other aspect is, in education mostly happens is when you are actually trying to gather data from multiple sources, and you might end up getting the same data which is being used in multiple, like it leads to plagiarism. So a lot of times this happens, particularly in the field of education, when you're trying to create a project, or whether you're trying to create a new course or new what is called as new workshops or something like that, right? So if you use AI, chances are that you may end up a higher conversion rather than repeating the same thing again. Now, other important area or application where AI is used is in manufacturing. In the manufacturing space, AI is used in almost every other places. Like it could be starting from procuring the raw material all the way till the what do you call it, selling the goods to your corresponding warehouses or to customers, however it may be. So in the entire chain of production cycle, you can use AI. And suppose imagine if AI, when used with the hardware, like in this case, suppose if you're asked to predict the temperature of a boiler, of an industrial boiler, which would go in the thousands and thousands of degrees Celsius. So would you be able to manually do it? Answer is no. Rather than that, you can actually use a device which will actually predict the temperature and then gives you the insights and says, okay, this is the temperature as of today. If you lower this temperature this much, then you will be able to get a higher accuracy. Or if you are able to rotate the what you call the workers or laborers, then probably your productivity may increase. There are a lot of data points it collects, and then you can use either predictive analytics or prescriptive analytics to optimize your business operations. Okay, this is about manufacturing. And manufacturing, there are a hell lot of use cases, to be honest, because manufacturing is one such industry where AI is used heavily. Now, AI, is that the manufacturing only used in the entire life cycle? Answer is no, because AI, once you have manufactured your product, unless until you sell it to the customer, that manufactured product is happening. So you could create a product, you could distribute the product to your corresponding customers, could be using your trade and logistics, and then you could sell the products to the directly to the customers or to the other businesses. So in any of the or in each of the areas, AI is helpful. Now let's see other important area of AI, that's in energy and utilities. Okay, energy and utilities. When I ask you, so what is the first thing which you make it? Renewable energy, right? Or you might even end up saying about Tesla or any other what you call autonomous cars as well, right? Because ultimately they also conserve energy, or they use energy in a different format rather than the conventional energy. They the autonomous cars, the ability of autonomous cars is not just in energy and utilities, but it is also in AI. Why? Because it uses what you call a charge, I mean the electricity, and then you can ensure that the autonomous cars optimize the fuel efficiency using the AI. You can connect that autonomous car to a cloud, or you can connect to any external device where you can actually ensure that the energy consumption is optimized. Right? This was not possible earlier. Now it is possible with the help of AI and particularly IoT devices. Similarly, if suppose if there is what is called as a windmill, right? So if that windmill is generating electricity, and based on the data that it generates the electricity in the particular month, probably when there is a what is called a lot of wind, you can ensure that I mean the blades of the windmill are tightened, because if there are a lot of wind and it may what is called rotate continuously and more than what is required, or it could lead to some catastrophe as well. So you can actually ensure that it is optimal. That is one thing. And also in other scenarios where there's not much wind at all. So what you can ensure is that you can loosen up the windmill in such a way that it rotates much faster. So in these areas, actually, you can use AI. There are many other areas in energy and utilities where AI could be used. Could be as simple as a light bulb, which I have actually in my home. So what we can do is we can actually use a smart bulb and connect to a cloud and use an AI to identify how many hours I use the bulb and how many hours I don't. Right? This was not possible earlier unless until you manually track it. Correct. So now one centralized system can actually track how much amount of energy is being consumed per day in your place. Right. So this is about energy and utilities where AI is impacting. And the other an important point over there is public sector, where you take any public sector a arena, which actually ultimately at the end of the day they have humongous data points. They connect to various enterprises, or it could be even for various customers. So in any scenario, if you are using AI to optimize the efficiency or the supply chain, if suppose in the current scenario you need vaccines, so if you are not able to procure vaccines in the right time, then what to do? Better you can use AI system to figure out where and how it can bring, or how the vaccination could be optimized. So those things will really transform the public sector, right? So this is what we have for this applications of AI. So let me just we have a quick recap. So applications of AI is profound in retail as of today. As I told earlier, could be offline retail or online retail or anything like that. But healthcare, healthcare is one area where AI could revolutionize in future as well. Not just in healthcare, doesn't mean it's always the medical. As I said earlier, it could be nutritional aspect, it could be what is called as personal fitness, or it could be yoga, it could be anything which is allied to healthcare also, AI could be used. And AI might have a humongous impact going forward, particularly in banking and finance, not just with the existing system, could be fraud detection, or could be loan prediction and other things, but also could be as complex as like the one which is in a huge news as of today, is that is about blockchain. Blockchain, particularly Bitcoin or any other coins, so which we have as of today. So in those areas also you can use AI and ensure that it predicts whether there could be a fall in the trading currencies or not, right? Because if it is a formal currency as what we have in the market, so actually there is a authority which will ensure that it is not devalued a lot. But if there is a distributed what is called a community network like blockchain, which actually distributed completely distributed ledger, so across the world. So there's no one entity which actually goes and tries to monitor everything, right? So in those scenarios, you can actually use AI to predict whether there will be a crash or whether there will be a huge bull scenario. So all those things, in particularly AI, is going to be a huge what we call factor in banking and finance going forward. Trade and logistics, as we discussed, particularly in the e-commerce segment, trade and logistics is profound as of today, and I'm pretty sure it will be continue to profound in future as well. And trade and logistics not just about within the boundaries; it could be outside boundaries as well. And also, I think one important aspect which I missed is infrastructure, like cloud infrastructure, anticipating when the cloud will be down, or anticipating the huge, humongous demand in the cloud, or anticipating the infrastructure failure, or the anticipating what is called as business continuity risk. All those things also could come in infrastructure. And in media and entertainment, also I'm pretty sure AI is profound as of today, particularly in the space of movies recommendations like Netflix, or it could be used for as simple as that ad personalization or targeting. So in all those areas, media and entertainment areas, AI could be used. And AI is already being used in educational field, and I'm pretty sure it is going to have a profound impact in future as well. So where I mean, if you know that you are more interested in AI, probably you will be more interested in Python as well. So we can ensure that, okay, if you are interested in AI, you can actually join our Python crash course as well, which is totally free of cost. If you want, you can just join along with the AI crash course. That's also free. So probably the description of those two courses I'll try to put in this link below. But at the same time, you can also ensure that there are quite a lot of what you call new courses coming for educational field. Okay, or new assignments, or new what is called as helping or enlightening, those things you can do in educational field. So probably you can enlighten your students in such a way that those students would not even be aware of such a thing existing. That surprises as well as enlightens the students, right? So in those areas you can use AI. Manufacturing, end-to-end manufacturing, you can use AI, to be honest. As of today, it's already being used, and I'm pretty sure it will be continuously used in future, where you can ensure that the product is created starting from your assembly line all the way till the what is called end customer. You can use AI to optimize the process, and it is already being used. I'm pretty sure, and continuously it will be used in future as well. And energy and utilities is another important aspect, particularly if it is an autonomous car, or if it is a light bulb which you are trying to analyze the consumption, and the various other aspects where energy and utilities, in those areas also AI could be profound. AI is already being used in public sector enterprises as of today, but also it will have major and more prevalent and frivolous when it in the future, particularly in public sector, because after the current scenario, public sector has suddenly emerged out of nowhere, that and realized how AI is going to have a profound impact in future. Okay, so there are quite a lot of other places also where AI could be used. Probably we do not have that much time for today, but I'll just give you some pointers towards the end, so you'll have an idea where you can go and search for other applications of AI. Okay, so now let's quickly move on to the other important aspect, that is the data visualization or the deep dive of AI. Before even deep diving AI, first we'll understand how the data visualize or data being processed, right? Which I said in the initial things initially. So, importance of AI could be framing market strategies, could be generating insights from data, it could be used for pattern research, it could be used for business optimization, and many other places as well. Now, as I said earlier, data collection is the first step in a data processing phase. So, this, if you consider data processing itself is a phase in a data life cycle. So, data collection is the primary thing, because unless until you collect data, you will not be able to do anything. So once you collect data, it's your job to input the data into your system. Probably if you have an online system, you're going to use the databases concept and then input all the data. Or if you are having any offline system, convert that offline system like a typical research survey or a feedback form and convert into an online form and then store it, because you'll be able to do quite a lot of data points and then do an analytics on it. Then you'll use processing to verify whether there are any missing values or whether there are any junk data, there are any whether the data is up to the mark or not. So all those things you can do in the processing stage. Then finally you will use output to arrive out of the entire process lifecycle, the clean data, and then that is going to be used for all the future purposes. So this is about data processing. Next, let's learn about statistics. So in the statistics, particularly the preliminary or elementary statistics are all mean, median, and mode. Where mean is nothing but your average values, median is nothing but your middle values, and mode is nothing but the number of frequencies, number of times that the same value occurs. So mostly, if I say about with what we discussed earlier about data types, like continuous data types, we'll use mean for it could be for mean, continuous data types again for median, or also it could be for categorical data types like qualitative data type, which we discussed earlier. Categorical data types you can use mode, where you can actually ensure that how many times the same value is repeating. That means there are more chances that it is important, right? So this is how we can use mean, median, mode, particularly in the field of analytics. Next, in the data visualization aspect, there are the data. Once we collect data from various sources, and if we do not visualize or do not analyze the data, and the data, if it is kept as it is and wasted, then that data is of no use, right? So it is better, as soon as we collect data, we need to sit and analyze whether that data is helpful, and if it is helpful, how we can use the data to make a better living for ourselves, right? So AI, in the umbrella of AI or data science, one aspect is data visualization. So is data visualization alone enough to say that AI is what is called responding properly? Answer is no, because in AI, data visualization is just one part of it. Data visualization alone will not be able to do any predictions. Data visualization alone will not be able to give you a lot of insights. It is ultimately the analysis of data that is going to be very helpful. And also, in the data visualization, there are multiple things. Could be pure data visualization. It could be something called infographics. Means where you will visualize the data and see whether that data could be storyboarded or not. Means it could be brought in a story form or not. If the same data could be modified into a story format, then it becomes an infographics. Means information in a graphical format. Well, data visualization is mostly used for visualizing the data, whether the data is having a lot of values or insights in it or not, and then bringing out of it. Okay, so that data visualization is just the starting of the process. That doesn't mean that data visualization alone is going to be helpful in doing any predictions as such. Then, if data visualization is so important, why don't we use data visualization every now and then? Answer is it is data visualization which is actually the key. We should rather go from data visualization do an exploratory data analysis, and then go with creating model rather than the other way around. So tomorrow, if someone comes and asks you like, is it okay if I create a model from the scratch without analyzing the data? You must say rather no, because data is something which is very crucial in the entire life cycle. If the same data visualization techniques, if you try to use in some other positive cases, you may not find any anomalies at all. So if the same infographics, if it is used to identify, sorry, not infographic, the data visualization to identify there is any fraud detection or there is any pattern of any hacking or anything like that, then using that data visualization, you can just arrive at insights, or you can actually create a model to truly predict whether there is any problem or not. So if it is a small data, you can just use basic data visualization techniques, that's no problem. But if it is a humongous data, then this data visualization or infographics technique is going to be having crucial and pattern there. What it does is that data visualization could be created as a report and could be automated as well. So, and those automated reports could be fed into AI models so that it derives some meaningful insight out of it. So this is one aspect of data visualization, particularly benefit of AI. So is the data visualization alone enough? Answer is no, because infographics also is equally important to market the or to what is called analyze the data. Okay, so next, then let's see the types of infographics available. So as of today, we have chart centric, list form, tutorial, timeline, geographical, process, comparison, interactive, hierarchical, and anatomy. So each of them actually have profound thing. Chart centric is mostly about the chart. Okay, so it's if you have quite a lot of charts, then why don't you go with the chart centric infographics? You can just give different charts for different scenarios and ensure the proper stakeholders are within the agreed lines. And you can ensure list form infographics. List form infographics helps us to list out each of the points step by step, and you will be able to know whether that list forms are what is called as catering to the customer's needs or not. Okay, the tutorial is nothing but the infographics handled in the tutorial form. You can guide them probably like a template or something step by step, and then providing the processes or access. Okay. Geographical could be your map data or could be geographical data where you can use infographics to represent whether the type of, if I take a typical example, if a Mexican grill is not available in non-Mexico region, so you can just ensure that, or if it is available in the non-Mexican region as well, you can ensure to create a geographical data and suggest where other places the similar Mexican grills are available apart from Mexico. So that is one thing. And also, you can also ensure that geographical data is used in the commutation or it could be in trade and logistics and many other places where geographical data is also being used. And also, process is nothing but if you want to represent a process flow from one place to the other place to other like that, then you can use process infographics to represent whether whether it is in the right form or not. And you can use comparison to compare between two types of infographics and see which one gives a better result. So like comparison in the sense it is mostly used as a comparison on hand, or there could be comparison automated as well, so using AI, so that gives more insights when compared to any of the others. And interactive types of infographics are almost always there. So like if you are asked to fill a form or a form in a web page, there's an infographics which gives you a web form to ask you to provide the data, right? So that is nothing but your uh, interactive infographic. So interactively, you will be able to get the insights. That is number one. Number two, you can also ensure that interactive infographics could be automated as well. So those are quite more interrelated ones. And hierarchical is infographics is where if you want to represent the data in a hierarchical form, probably like father and son relationship, or the mother daughter relationship, or mother son relationship. Based on that, you can actually ensure who likes the particular type of movie the most. If I take the example of Netflix understands probably your son who is age 8 years probably would like one type of sci-fi movies, and Netflix may also understand that your spouse may be liking more of a particular talk show rather than something else. So all those things you can actually ensure in a hierarchical format and then feed to the system and ensure that the system understands all the hierarchical data, whether that hierarchical data could be used for data processing or could be used for data analytics or not. Those things also can be found out. Anatomic is mostly used for anomaly detection is for anomalies, but anatomic detection is for mostly to check whether the health of the particular data is up to the mark or not. So it's like anatomy, doing analysis or doing critical analysis on the particular type of data. So in all those scenarios, you can use infographics. Next important aspect is business intelligence. In the business intelligence space, you can actually ensure you can have a data provided with lot of insights coming from various sources. Particularly in the business sense, if it is a beat, there is that you can have a data connected from a business to business, or you can have it connected from business to consumer, or even from business to consumer. There are a lot of places from where you can actually collect data. But the true power lies in analysis of the data. So once we collect data, if we are not able to analyze it properly, then that data is of no value. So it could be like first or second step before proceeding with further AI. Business intelligence is mostly used for descriptive analytics, and also it could be sometimes used for even diagnostic analytics, where you can get a fair understanding about the past data and see and predict what might happen in the future based on your intuition, not from system, but at least from your intuition. So there are a lot of business intelligence systems as of today. I'm not denying it, but business intelligence is not something new. It was there earlier also, and even today it is there. But albeit like now reporting and scheduling and many other aspects could be automated when compared to the earlier segments. So, and also in business intelligence, you can actually create a primitive model, probably like an algebraic model, to predict whether your outcome, predict the outcome which you want. Okay, so a lot of places where business intelligence are used as probably we'll touch base upon some of the important aspects in the future. So, if I ask you, can we do entire business? Can we create a model just with the business intelligence tool? Answer is no. If there is a small amount of data, and just a basic or a application could be created with business intelligence tools like Power BI or Tableau, but those also needs to be trained or to be educated in such a way that it gives a proper insights. Business intelligence is a whole what we call very large topic. A lot of ways we can actually use business intelligences. So probably some of the things could include Tableau and Power BI, and these two are the profound applications which help to do business intelligence. There are many other places also where you can use where we can do business intelligence, particularly without any app. Even with just Python code, also we can create some plots and other things, and do some basic exploratory data analysis for on behalf of business intelligence. So in our next session, we'll learn about the future of where the AI is heading, and also we'll deep dive in Python programming because that is something which will take quite a lot of time, and probably we will go further with Python programming. May not be able to test R programming today because of paucity of time, but at least we'll go with Python programming in detail and see how we can leverage Python programming for AI. And also, if we have the time permits, we'll discuss about machine learning on Azure. And let's see how that how we can actually use Microsoft Azure to do machine learning analytics, right? So if we have some time, so we'll definitely touch base on that as well, and wrap up this with a career path and the future scope in AI, and that will give you a good insights of where the AI is heading to. Okay, so what I will do is I'll try to quickly share my screen to show you about the Python, and where we'll dive deep into the Python and see how we can use Python to do basic AI. Okay. So let me quickly share my screen back. Okay, so this is about the Python crash course. Okay, so I'll quickly take a quick pause to see if anyone has any queries. It's about the Python crash course. Okay, so okay, I don't see any queries as of now. So if there is any queries, guys, please do not hesitate to put a comment below, so I'll be able to check it out. Right. So now, what is this Python crash course mean? Right. Python crash course is nothing but 5-hour crash course, so which we have developed. So where we'll try to help you out how we can start with Python, and how we can use Python to do some basic AI and exploratory analytics and other things. So probably will not be able to touch the complete machine learning, but yeah, we'll see how much we can do it. Yeah, if we are able to do machine learning with the stipulated time, we are, if not, then probably we'll give you some exercises, so you can at least do it on in your free time whenever you have the time. So now, in the Python crash course, we will see what all the following topics we'll cover in this Python crash course. Probably we'll start with the genesis of Python, so where this got started from, and we'll next touch base upon the features of Python. We'll see why Python is now the preferred language for data science particularly, and where is the Python used. I'm pretty sure that it is being used in almost every other places, but yeah, let's go step by step to see where it is being used. And also we'll touch base upon how we can start with Python. Probably we'll see how we can actually use how we can install Python, and also how we can use Python to do some basic stuff. Okay, that we can also proceed further with magic of Python. What magic of Python is not any magic things, but we'll do a lot of coding to see how we can use Python for better. Okay, and this should give a good grasp on Python, to be honest. And then when you have a good grasp on Python, you can also ensure that Python could be used not just for one particular model, but also you can create a model, and you can ensure that same model could be reused for multiple purposes. We'll see, but if we have time, we can actually create something. And also we'll try to see the future scope of Python before wrapping the session with the and move back to the artificial intelligence. Right. So I'm pretty sure this will itself will take around a couple of hours, but let's see how best we can utilize that time. In the Python, actually Python was it's not something new. It was actually envisioned by Guido van Rossum in 1991 itself, and it was developed by a Python software foundation. Okay, and to be honest, actually Guido van Rossum was working in a company called as CWI, Centrum Wiskunde and Informatica in Netherlands, where he was working for ABC Group, means to what we call the actual developers of ABC. ABC itself is a general purpose programming language. Back then it was quite popular, and he was also a part of it. Okay, and when he learned over there, because they had their own operating system for Amoeba distributed operating system, and ABC, when it was trying to talk about, there are a lot of things because ultimately any operating system, if you want that operating system to do some operation, you need some commands, and those commands could be used through either a high-level programming language or through a low-level programming language or through a machine language. So instead of using definitely machine language will not be able to understand by the typical humans, but at least assembly language could be used. But assembly language was also used, and but afterwards a high-level programming language started back then in 1980s. C started first, and then C++ and then Python at the same time. ABC was there. There were Ada. A lot of other languages also was there at that time. But ABC was quite a popular general purpose programming language back then because of its flexibility in using the same programming language in multiple applications. Now, when Guido van Rossum noticed the problems of ABC programming language when talking to a Amoeba distributed operating system, he learned that okay, ABC is such a programming language which has to be talked with Amoeba distributed operating system, and if there are some exceptions or errors which if it occur, then ABC was not able to handle it properly. So there were no exception handling mechanisms back then in APC. So this led for him to think, why not to create either fix the existing programming language or create a similar type of scripting language like ABC to which actually handles not just Amoeba operating system very well, but also it could handle any other operating system which might come across in the future. So he was such a visionary that he looked forward for all types of what we call he tried to go to solve all types of problems which were prevailing back then in ABC, and also ensure that it will be an extensible programming language that back towards 1989 and 1990 he had some time and he made so extensible that it will be like a base skeleton, and you can actually put on top of it different types of modules and different types whatever operations we want. It's just a matter of getting them. It's like just in time resources. So if you are asked to create a what you call sorry some new dish or something, right? So what you will do if you do not have a particular ingredient, you will try to either borrow the ingredient from other places or use the existing ingredients, right? So a similar thing you can envision over here. Like he ensured if there is already available, he just try to enhance them. If it is not, if someone else has it, why don't you borrow them and then use it for your purpose? That is what is called extensibility. So that he envisioned. And also he ensured that there is a proper exception handling mechanisms, particularly for the Amoeba project, but later on it was even extended for other operating systems as well. Python started initially with 1.0 and various subversions till all the way till 2000, and a lot of additions and new bug fixes and all happened in even 2000, and they actually released with some limited amount of features, but those features were at least good amount back then. I'll not say were huge, but at least good enough back then. But it was in the year 2008 when Python 3.2 was released with more testing and new features, because by the time the data also had increased, number one, and also business scenarios were changed, number two, and also Python was gaining a good traction with various other programs, like it could be web development, it could be data science, it could be scientific analytics, and many other places. It was actually considered to be a good contender. So Python started getting good traction back then. So this is about the background of Python. Now, if you ask me, the Python is it the only good operating system? I will say no, because good language. I'll say no, because there are quite a lot of other languages also existed, and particularly in the languages, programming languages, there are two major things, major types of programming language existing. One is called scripting language, and another is called full-fledged programming language. Scripting language means a programming language that supports scripts, but programs are written for a specific runtime environment or specific task. But for a formal language or called a programming language, it comprises a set of instructions used to produce various kinds of output. Means you could use same programming language to create a web-based project, same programming language to create a Windows-based or a graphical-based project, or you can use the same programming language for what is called altogether a data science application or anything else as well, scientific analytics as well. So, but scripting language, on the other hand, is designed for some specific purposes. And Python initially, from the starting itself, Python was meant to be extensible, and hence I will not say Python is pure scripting language, but at the same time, it has the abilities of being both scripting as well as programming language. So let's cover all these things in the next slide. So I'll tell you. Uh, then execution speed is a bit slower in the scripting language. There are a lot of scripting languages. I will cover those as well, but it's generally slower because it's mostly an interpreted language. Meaning like you directly execute them in your PC whenever it's required. While programming languages generally are compiled languages, means they generate something called as intermediate language or machine instructions in between, which will ultimately help to execute the machine. And this leads to a faster processing and a bit higher what you call speed when compared to a typical scripting language. Now, uh, and also, the scripting language can be divided into client-side scripting language and server-side scripting language. Meaning, like you can ensure that some of the languages are executed only on the client side and not on the server side, and some of the languages are executed only server side, not on client side. And some of the languages could be executed in both the places. Like JavaScript is a very best example, used in many places. And yeah, there are other things we'll see that, but typically the formal programming languages can be divided into high level, low level, and languages, or also compiled based or interpreted based languages. Like some of the languages are compiled based. Most of the languages, in fact, are compiled based languages. Probably like C, C++, .NET, Java. They're all compiled based languages. But there are some interpreted languages as well. I'm denying. So it could be like PHP, could be Perl, then many other programming languages could be just an interpreted language. There are no compilation required for that. But at the same time, that there are advantages and disadvantages because compilation-based languages are generally faster compared to interpreted languages. Now, not all formal programming languages are compiled-based languages. Some are interpreted languages as well. Okay, I'm not denying it. But it is very easier to learn scripting languages and compared to the programming language because scripting languages, since they are defined for some specific purposes, it is easier to learn. But having said that, there are examples like JavaScript and Python, which are so what is called it has become a de facto almost for web development and data science. So JavaScript is for web development and Python is for data science. So what happens is that in the JavaScript and Python both being flexible enough to be a scripting language, at the same time it could be used as a full-fledged programming language where you don't need to do any compilation, but it could be directly used for interpretation, and also ensure almost all types of functionality are present in both of them. Like JavaScript and Python both could be made as object-oriented language, both could even act as a procedural language or typical function-based language as well. Now, having said that, there are some missing things present in the Python. Like if I take about encapsulation property, typically present in any object-oriented language, it doesn't have. Python natively doesn't support any encapsulation, though there are some workarounds by putting in underscores and all, but natively doesn't have any encapsulation properties, though it has inheritance, polymorphism, and many other object-oriented properties. Yes, so that is one thing, and also mostly used for web development. Like scripting languages are mostly used for web development, and that's what I was trying to say. But like Python could be used for even for data science applications as well. I'm not denying it. Now, in the programming language used to develop various applications, could be desktop, web, mobile, and many others. So I'll not say Python could be used both as scripting as well as programming language, but it depends. if you are using Python only for what I can say, Python is only used for some specific procedural types. It could be acting as a scripting language. But if Python could be used for some object-oriented and complex type of functionality, it could be acting as a formal programming language. So it depends on the use cases and the scenarios as well. Similar case with JavaScript also, because JavaScript is also so advanced now. Nowadays, like you can actually create a DOM object, you can create a jQuery. A lot of things are available even using JavaScript and create using JavaScript. Having said that, JavaScript is also can be used both in scripting language as well as a programming languages. Now, this is about the languages percent. Why Python or where Python is having. Now, we'll revisit. Now, once we know the languages and the impact it brings, we have to even see features present in the Python. Now, Python is very easy to code. And also, I must add, I forgot to add, it is very easy to learn as well. As of today, most of the universities are now teaching along with C, even Python. C is mostly used for system-based programming language because Python per se is an interpreted language, so it is a bit slower when it is trying to be when it is used in particularly when talking to systems or operating systems per se. While C is natively much more faster. And there are ways how you can tweak Python to, there is something called object Python. So where actually you can natively convert Python to C, C language. Okay, so I mean there are ways you can convert. I will not say natively convert, but there are ways to convert Python code to C and ensure that the system is executed faster. So let's not complicate it further, but as of today, Python is considered to be very easy to code. Okay, there's no other doubt about it. And also, Python is free and open source. You can create an application in Python without any hindrances or without any hiccups, and nobody is going to question about it. Having said that, it is you can create a Python code per se is free and open source, but the application what you create could be made proprietary. How? You can actually create a wrapper around that application which you are going to create and ensure that wrapper is commercialized rather than the code. Okay? So you can just create an API and leave the API to the external world, and API can be made as chargeable. Okay, that is number one. Number two, you can actually use the Python code to create or extract data, and you can extract and you can use that data as a service and then commercialize it. So there are a lot of ways we can actually use Python to, though you can consume them as a free, but you can also commercialize them however you want. Then, what is object-oriented programming language in Python? What I said, like encapsulation is one such property which natively Python doesn't support, but there are ways you can actually use underscores and then overcome it. But almost every other aspect of object-oriented programming language Python supports. Okay, there is no other better competitor for this. Why? Because particularly in a data science field, if you are having a lot of packages or a lot of programming to be done, use Python one programming language as a backend and then do a lot of operations. You can connect to a web development frameworks like Django, Flask, Pyramid, Python, and many other languages also are there. Web frameworks are there in Python, and also, you can ensure that you can connect to data science packages, could be, or you can import some of the math libraries, or could be import or data frames, or mathematical functions, or graphs, or a lot of ways you can actually use object-oriented programming language there as well. Now, Python could be used even as a high-level programming language, and I'm pretty sure it is one of the very flexible and portable language out there. Why do I say so? Because as I said earlier, it's very easy to code, number one, and also it's just a matter of using the same code in whichever operating system where you want and executing it. Since it is an interpreted language, almost every other operating system, when it is
deployed into the corresponding runtime, it just executes, right? So the same set of code, same set of and because under the hood it actually converts the Python to a machine level format itself. So because it's an interpreted language, and Python, I'll not say always as a system language, it excels, because as I said earlier, it could delay or delay the time to execute. That there are some challenges, not denying it, but portability is still uh, on the top of I mean, it's one of the most sought out feature of Python. Okay. And integrated language means it could be integrated to almost any other type of application. So it is not just limited to other Python applications per se, because you can actually create as an API and use it almost any other places. So interpreted language, this is what I said, it's not a compiled language. It will execute during the runtime, and hence if you do not use the proper set of instructions, it could lead to a lot of time. Okay. So that is where interpreted language is there. But having said that, the other advantage is if it is done properly, your execution could be done faster as well. And there's no comparison again required to if there are a lot of business changes happening. So every time you otherwise you have to go to a compile the code. That problem is not there. Interpreted language in the large standard library also exists in Python, meaning you can that's what I was saying. There you can actually import math functions or development frameworks or whatever however you may. So all those standard libraries have been created not just by Python foundation itself, but also Python community, developer community, who could be like you, me, or anyone else. So we can actually create our own libraries and give it for the benefit of the rest of the members. So that is what is called as large standard library, particularly in the Python community. Dynamically typed language is something where actually you it's like similar to interpreted language. So, and also it will ensure that whatever data types which you assign to the variables, corresponding variables in Python, it will infer from it. So we'll see all these points in our next slide. So probably then we'll have a better idea. Applications of Python. As I said earlier, Python it could be used in various varieties. It could be used for string processing, it could be used for internet protocols, it could be used for web development, it could be used for software engineering, pure software engineering concepts, or it could be even used for operating system interfaces, albeit with some limitations. So, yeah, string processing is something where it is more highly used as of today. I must say, regular expressions could be used in Unicode, so changing, calculating difference between the files, and a lot of other places where Python is used, particularly in the string processing field, and it is going to be continuously researched across the globe, because regular expression is something which is a niche topic, to be honest, and a lot of other avenues have come, natural language processing, or it could be web scraping, and a lot of other arenas also has come in the similar angle. And also in the internet protocols, it could be used for web development, as what I was saying. Web frameworks could be used for different types of analytical, what do you call it, web development applications, and web type of programming. You can use Python. It could also be used for pure software engineering concept. It could be unit testing, it could be logging, profiling, many other places also. It could be also used for operating system interface like system calls, file systems, and also TCP/IP sockets. Albeit I'll say that there are some caveats that about high execution time, but it could be used in multiple places. Now, this is the most and exciting opportunities in Python. Python could be used for various applications, particularly in data science, I'd say, which I should have mentioned. Deep science, deep learning, Python excels from the rest because a lot of libraries are already inbuilt, and particularly after TensorFlow from Google, it is now considered to be Python is considered to be de facto to learn deep learning. You without learning Python, people will say I mean, it is not, it is very difficult to believe that you even can able to create a deep learning project, right? It has come to up to that stage.
Machine learning, yes, machine learning, Python is also helpful, but at the same time, there are other ways also you can actually create machine learning models, not denying it. But Python, if you learn Python, learning machine learning and deep learning, it will be much easier and you'll have higher opportunities in it, since it's just one language to learn. And it is also used in predictive analytics for some typical to machine learning, and also advanced analytics could be used even for prescriptive analytics and for this. And also it could be used for as a scientific research. Typical researchers like in healthcare and other areas where they're typically not for what is called exposed to formal programming languages, they can also use Python to do a basic exploratory data analysis and all. That's what I'm saying the next one. And also in the data science, as a gamut, it could be used in almost every other aspect of Python, data science. Python could be used, and also in statistics, basic statistics, and also up to a level, statistics could be used in Python. Albeit, I'll say for statistics, even today, R is considered to be one of the very robust language for statisticians. And also, it's because of simplicity. Having said that, Python is going to beat R in the coming future because of its versatility when coming to the programming. Now, this is the important thing, guys, like Python installation. So, if you ask me how I learned Python, so I actually installed Anaconda. I installed various environments in Anaconda. I create new environments and ensured that each environment could be used for different projects. And while I installed Anaconda, I also ensured that Python is installed along with the Spider and Jupyter Notebook, because Spider, though I do not use much, but at least Jupyter Notebook I use day in and day out. So, what is Jupyter Notebook? You may ask me. Jupyter Notebook is like a step-by-step instructions which you can execute to see whether you are in the right path and whether you are able to create a program in the right way or not. So that, and also you can use it to share that the Jupyter Notebook which you create across the other members who you may need the code. So, and since it runs on a web server, Jupyter Notebooks generally runs on a web server. It could be in your local web server, it could be in your internet hosted web server. One best example for Jupyter Notebook hosted on internet is nothing but Google Colab. So Google Colab is under natively supported, natively supports Jupyter Notebook. So it's just a matter of importing Jupyter Notebook into Google Colab and start using it, right? Because Google has provided that native integration of Jupyter Notebooks inside Google Colab. Now, if you ask me like what Python IDE I typically use Python, PyCharm or the Visual Studio Code. As of today, I'm using Visual Studio Code, but earlier I used to use PyCharm. And also, I have explored about the Spider, but I will rather prefer an enterprise tool than the Spider over there. Scripting in Python, yes, scripting you can do in Python. I generally do scripting in Jupyter Notebook, to be honest. I'll not use directly Python or anything. Um, yes, if it is for what is called as just as a hobby, I started using Python IDE like PyCharm and Visual Studio, Visual Studio Code particularly, not Visual Studio Enterprise or something, but Visual Studio Code, where I imported Python modules and started learning about Python. But having said that, for all my assignments and other places, I generally use Jupyter Notebook because that gives a step-by-step instructions and it is easier to share across the members. Okay, right. So now, typically, let me share my screen and show you how I install Jupyter Notebook. Okay, I'll quickly take a pause. If you have any doubts, let me know. Okay, so Jupyter Notebook has started. So what we will do is I'll quickly share my screen and show you the Jupyter Notebook which I just started up. Okay, so as I said, I generally use Anaconda. So because Anaconda is nothing but a software deployable package, natively supports Python and many other things as well. Okay, so that's what I said. So in the Anaconda, I'll start a Jupyter Notebook command. So what will do? It will actually deploy a notebook to the local. It will actually create a new port in 8888 and deploy all the notebooks into the local host 8888 port, so that you can actually use the Jupyter Notebook to execute all your Python programs. It's not just used for Python; it could be used for many other languages as well. But it is mostly preferred for Python because as of today, uh, it is almost every place it's being used. Now, let me go to the Jupyter Notebook. If you're able to see, this is called Jupyter Notebook. So what we can do is we can go to the exact place, Python basics, and let me go to dashboards. We have a lot of programs over here. So as I said, once you are installed Anaconda, it's just a straightforward approach. You could, while installing Anaconda, you could also ensure that it is whether it is installed in the path variable or not. So that is up to you. But I generally prefer to execute the Python from within the Jupyter Notebook. So IPN IPYNB means IPython. So IPython is nothing but an extension for typical Jupyter Notebook. So IPython notebook, NB stands for notebook, IPython notebook. So that means that's it. So I'll try to start with the introduction to Python. So probably that will give a better idea of where we can start with Python. If you are aware of all these things, please let me know. If you have any queries about any installation or anything, you can just put in the comments below. Now, let's start with the basics of Python. Okay, so basics of Python could include the primitive data types, and also it could be could include the advanced complex data types as well. So let's start with primitive data types. So there are numbers, strings, lists, and dictionaries in Python. Now, if you ask me, like, numbers means what? All integers and floating point or decimals is also called, and as well complex y equal to mx plus c come under this number. So complex doesn't mean that over here it's a very collection type of what you call data type. It is just like it is represented as y equal to mx plus c, something like an algebraic equation. Though I would highly discourage you to use something like that unless until there is some absurd use case. Rather, we'll go with the integers and floating points numbers itself, and we'll touch base upon strings as well. So we'll see how we can actually use various string functions, and also we'll touch base upon lists and dictionaries, and quickly see the difference between tuples and the sets out there. Okay, so we will start with numbers. Okay, so numbers. The numbers, as I said earlier, you can have an integer or you can have a floating point number, and you can also have an do quite a lot of mathematical operations on top of it. So numbers, as we know, is a quantitative data type, and it's a discrete data type where it cannot do a further analysis on it, further what we call a breakage on it. So uh, in the numbers also, that is for integers, you cannot do a breakage, but for floating point you can still do a furthermore bifurcation of it. So both integers and floating points are being what you call, we can actually use both of them in Python. Now here, if I take the example of 12 plus 45. Okay, so this is a Jupyter notebook. So Jupyter notebook generally has two sections. One is an execution codes, and that is called command code. So you're all on command code, your execution code. Execution place is where place where you provide interactively to the system what type of command you want to execute. And when you put like 12 plus 45, system understands, okay, you want to try to compare add 12 with 45, and then when you press shift enter, it provides you the output. Okay, so in this case, some of the outputs are already coming because I have executed earlier, but just to give an idea, so this is how it works. Now, you can do similar a lot of arithmetic operations like additions, multiplications, and also you can do something called the raised to the power. So here in this case, it is double star means raised to the power means 2 raised to the power 6 means 2 to the power 6. So what is the value is 64. And if there is only one single star, that means it's time to multiply and then give the corresponding value. So there are multiple ways you can actually do it, and also in this scenario where you will have multiple operations in the same expression, what you can do, you can ensure is that you can actually provide braces to all those places where it is important, and then provide the corresponding expressions, operators in the expression. So this ensures that the value is 65 minus 34 and top of 4. So then if you are other important aspect is about the variables. Okay, variables in Python, and that is a whole different topic which we'll take in next one. But just to give you a background over here, if the value A is less than 10 and the value B is less than 47, what is the value of A plus B? That's 57, right? So in this case, you know values of each of the value, each of the what you call variable. Then you're trying to print out. Suppose if you're trying to print directly A over here and without even initializing these values. Okay, if you remember, like I was trying to say about dynamic assignment in Python, this is what it means by dynamic assignment. It means you can dynamically assign a variable with a corresponding value and let the variable inference what is the data type of the corresponding value. This is only possible in a language like Python, because unless until in most of the other languages you have to actually mention to them that what type of data it is going to hold. Having said that, there are advantages as well as disadvantages. To be honest, there are scenarios where it actually should not take it as a number or a floating point number, but it takes. There are some scenarios where and generally floating point numbers will be automatically converted. I'm not saying about floating point number, but in strings. Suppose if there are some string values, and if you are trying to assign a value to the string or any other operation to the string, then the same string could behave differently. So we'll see about each of them when we go by. So now, just to give background, this is how we are assigning the value. If I'm putting 10 out to the A and assign to A, the system automatically understands it's an integer and it is going to give the output accordingly. If suppose if we had something else, show you that we have strings. So yeah, let's park it off for now. Print of A. By default, if you do only this much, the value will not be stored back in where. So if you directly type the same thing again, you will not be able to get the same value. So what I'm to ensure is that you need to assign that value to the some variable, and only then you have to print the value. Then only the value which is assigned to the variable will be printed, otherwise it won't. So this is about the print value. And there are something called as if you are asked to identify, suppose what is the maximum floating point value or decimal value the Python accepts till 1998, sorry, till the of late 2008, 2018 or 2016. I don't remember exact year, but till then we had long int also in the integers. But as of today, integers do not have any long int anymore. So integers natively support both int and long int. But floating point numbers are still ranging from the negative part to the negative value to the positive value. Meaning, floating point numbers earlier was considered to be a function of some value, and today, though it is still considered to be e to the power 308 and considered as a function for a value, but it is still considered to be what it is still helps us to do our corresponding program, right? Now, let's learn about the strings aspect of here. So, the strings, you can actually use a lot of things like typical string operation of any program language that we learn is print hello world. The same thing which I have done over here. So I just try to print hello world over here, print along with the angular brackets. When you provide a value, it becomes the value which needs to be printed out. Now, this is a string which I'm trying to assign to my string, and when I'm printing this my string, then I'm getting the value as this is a string. So now, because this is a string, this string value is being assigned to my string, and tomorrow if you are going to assign some value 3 as it is, system going to assume my string is value 3, and that is an integer data type and not a string data type. So it is our responsibility as a Python developer to ensure whether the value which is being assigned to the corresponding variable is correct or not, right? So and also we can actually ensure that what is the string length of the value which is assigned, that if we can use a method like length function len and then pass the corresponding string, and you can actually return the corresponding characters present in the string. Now, if I directly execute len of my string, you will get an error saying that my string is not defined. Why? Because my underscore string is actually over here, and unless until I execute this over here, when you try to directly execute len of my string, you will get an error. And because system doesn't know that what is my string, it is trying to get confused, then to an error. Now, if I execute my string first, and then if I try to print this string, it will still show that my string is not defined because I'm trying to print. So let me use my underscore string first. Okay, then it will show this is a string. Now, because this is now currently corresponding assigned, now we know that my string is already having a value. Now, if we are trying to put length of my string, it will give the correct value, that's 17. So unless until the variable is assigned with some particular value, when you're trying to execute, then it will turn error. So it is our responsibility as a developer to check whether it is properly assigned to that the corresponding values or not. Now you can use string concatenation operator. There's something called plus, which we saw earlier. That's also called as operator overloading, where you can actually use the same operator to and allow the same operator to perform multiple operations. So this is nothing but operator overloading. And here, two strings are being concatenated. One is my string and other is 3 marks. So now, when my string and 3 marks are concatenated together, it actually prints the value. This is a string in the inverted comma along with the value 3 marks, which is going to be appended to the corresponding value, corresponding string. So, though if I ask you like now tomorrow, if you're directly going to try to print of my underscore string somewhere here, then what would be the output? Can you guess? Is it going to be this is a string three colons or four exclamatory marks, or it is just going to be, is it just going to be this is a string with one exclamatory mark? Yes, you're right. It is going to be this is a string one exclamatory mark, but not the 4 exclamatory mark. Why? Because we have not assigned this value back to any other variable. If had we assigned back this my underscore string equal to my underscore string plus 3 exclamatory mark, probably if you print my underscore string later, it will still bring this is a string with 4 exclamatory mark. But now it's not the case. Now let's move on to the functions. In the functions, there are a lot of things possible in functions. To be honest, Python could be used both as a function programming language as well as object-oriented programming language. Having said that, functions is very useful to make code reproducible. What do you mean by code reproducible? You can use functions. Functions to group the chunk of to group the code and ensure that this group of code is executed wherever required. So in this case, we can actually create a function with a diff keyword and give a function name and pass the corresponding parameter values or arguments. It's also called arguments. And then in the next line, if we print that if we give a statement with 4 spaces, it ensures that the entire thing is a function and all the values within the all the lines below this diff keyword with the indentation is enclosed within the function. So tomorrow, if you are going to put one other value line over here with the same 4 spaces, then it is going to assume that the new line is also part of the same function. However, if I'm going to put another line with a no indentation and then give and provide a system and thinks that the function is only till here and then the rest is some other program. So in this case, it understands, okay, the value is only till here, and then it tries to go to the say hello to A. I have created 2 functions, and I'm going to call this function somewhere down. So probably you'll have an idea. So age of person, we're actually yeah. So okay, let me just come back to this once actually thing is there. But just to give you a background, what I'm going to do is I'm going to call this say hello to age or say hello to name, whichever is required. So if I'm going to give a insert below, and if I would put a value say underscore hello to name, I put Arun. So save it. Now, if I directly try to print this, what will happen? It throw an error because it doesn't know what to say and go hello to a name. So in Python, even a function is treated as an object, and an object, if it is not initialized, then it will throw an error. Okay. So in Python, even a function is treated as an object, and if the object is not initialized, it will throw an error. Now, we have not initialized this object. We did not run this object. So now if I directly run this object, okay, and then if I run this, then it will give me correct result. Hello, Arun, pleased to meet you. The same thing would have occurred for say hello to age also. Like if I don't execute that, then directly I print hello to age, probably the same error will come. Okay, so that is something to be noted. Now, if I print say hello to age of 21, 21 will be passed over here, and this 21 is going to be assigned to age of a person. Now, if you go and try to see the type of this age of person, data type of age of person, to check whether it is a integer or whether it is a string, you'll be surprised to know. Because if I now just directly try to print int of age 21, so it will tell you that integer is the value of integer or age of a person. But at the same time, it is also going to say you age is 21. Your sorry, hello, your age should be not you. Your age is 21. Okay, so if I now execute it again, it will come as you are. Okay, I didn't execute this way. Why is it not working? Say. Okay, so it did not execute again because it already had a previous cached value. So what I did, I passed a new value, and then it has re-executed and given the correct output. So now it is hello, your age is 22. So now when you pass this back to over here, then it tries to understand, okay, age is now part of data type. I mean, data type is of integer, and then assigns the age of a person. Now this type of age of person, when you try to print as an integer. So this class will come as integer. Now, when you try to print hello, your age is string of age means what we are trying to do is actually when you are, if you are directly going to, okay, let me do one thing. If I just put like this, what will happen? System will throw an error because age per se, system doesn't know that age is something which is okay. I should rather okay, so it is expecting end of this, that is this, sorry. Okay, so now what happens is that system is actually going to, it doesn't know what is the value it is going to be assigned to, right? So system assumes this age is a string. Okay, so now if I now go, if I try to go here and assign, I mean, pass same thing again, what system is going to do is going to throw an error because it is assuming that it is going to be a string, but what we have passed it as an integer, and this can only contain a string to a string, not an integer, right? So for that, what we did is we, instead of directly putting the age, we're trying to convert that to a string and then print it. So if I now give the system like this and then ask it to do, then it actually converts this age to a string and then concatenates, or this plus is there for use as concatenates, which I said earlier. So concatenates and then use the corresponding input. So this is very important because the similar conversion functions, there are multiple ways we can do. So I don't know, we have that much time to do, but yeah, see, we can actually use curly braces. You can use earlier we used to even have percentage as similar to C language, where you used to have percentage similar to that. We used to have this one as well, but this is not being used much. Curly braces is still could be used, and there are like string format functions are there. Like that format functions are there, so you can actually ensure that all their values are formatted. This was one of the variable, one of the way you can actually format this to string, but there are other ways also. Okay, probably we'll see some of the things in future, I guess. Let's see if I'm able to get some of the examples I'll show you. Now, we have seen till here, and also okay, suppose if we are trying to use a small functions like diff circle area of radius. So this is a function, and we know that radius is being passed with the value which will pass from here. So in this case, it is an integer. So if we are passing integer over here, okay, and the pi we have assigned a floating point number. By default, system tries to convert this value. Okay, so if okay, now let me try to directly execute this. You get an error because certain area is not defined. So that function is not defined as an object of there. Now, if you try to execute, by default, this 24 will be treated as a higher one. That means it will be treated as a floating point number, and then multiply the value and raise to the power 2. Then that would give the value 1809.55736. So this is how some places with Python automatically converts, some places it doesn't, and wherever it doesn't, it is our responsibility as a Python developer to convert it to the corresponding or the right format, right? So that is about the function. So now let's learn about the list in Python. There are quite a different ways to represent list in Python. You can actually use a square bracket and then pass on the values. That is one. Okay. Now, first, before you proceeding further with the list. So what is list in Python? List is a collection which is ordered and changeable. What do you remember? List is a collection ordered and changeable, meaning like you can actually put multiple values into a or multiple objects into a list. It could be same type of data type, or it could be different data type altogether. There are multiple combinations you can do, but you can store in a square bracket to a list. Okay, and the list understands, okay, it has to store all these values, and it stores in an orderly manner, meaning that value 12 will be stored in the index of 1. So each list will have an index. Each of the values which you store will be ultimately stored as an index. That index will be stored in the memory. So this 12 will be stored as in the first index, 6 will be stored as second, 3, third, 4, and so on. Okay, so this is nothing but your list. Now, the same list could be even represented as a list keyword. Say list, but only here you need to ensure that there is double this one, and then pass the similar object 63, 3, and others, right? So now if I directly execute this, it will throw an error. You know, like it will not arrow. Now, if I then try to print, it will print the entire value. Minus will print the entire value. Now, ordered means nothing but what I said is about indexing. So it will store linearly or sequentially, it will store all the values in the corresponding list, and you can access it with the indexes. Okay, so that is something like index. I'm going to say this over here, like my underscore list of 0 will give the value 12, my list of 10 will give the value index out of range, because there is nothing like 10 out here, because it starts from index in the list will start from 0 to 9. Because though there are 10 values over here, because string length, if you put, then you get a value 10, means like 0 to 9 the values are being stored. But if you're trying directly access my list of 10 is 10th index, there is no 10th index, and it throws another list index out of range. So now if suppose if I'm accessing my list of 9, then I'll be able to get the 89 value, because that's the last value which has been stored. Having said that, if I directly use my list of -1 means I will tell to the system saying that you traverse from the backwards rather than the front. So if I do not give any negative sign, this system will traverse from the front to right. If I give it the negative sign, the system will traverse from back to front. So that is the one difference. So in this case, it will give the value 89. My list of -1 is similar to my list of 9, so it will give 89. My list of -2 will give 92 value. It's like similar to my list of 8. So which will give the 92. So you can actually traverse from both front and back. This was a smaller example because we didn't have much data. Suppose there are large amount of data, it's impossible to know what exact index what values are there, right? So generally we use something called as looping, which we'll see next. Now, so now similarly, if I'm asking what are the fourth and fourth last elements of my list, so what would be your answer? I'll take a one. What is the fourth and last fourth? It is 0, 1, 2, 3. This is the fourth element. For when you are coming from the reverse, then you do not have any 0, right? So you will directly use -1 here. -1, -2, -3, -4, that's 63. So you can actually use my list of O. Now this should give you value. My list of O should be 0, 1, 2, 3, 26. My list of -4, 1, 2, 3, 4, 63. Okay. My list of 4, 0, 1. 0, 1, 2, 3, 4. Okay, I have got 4, not 3. So that will become 10. Sorry for the confusion. So this is 10. Okay, so right. So then my list dot append. So what it does is that it actually appends the whatever value which we give for the list. So in this case, we are going to give -4. So what it does is that already on top of existing 10 values, it is going to append at towards the end. And hence it your in next list when you're trying to print, you'll get -4 value. Now, if you are trying to print length of my list, when you're trying to print, it will give 11. Okay, that's one thing. But most important aspect over here is you can actually concatenate two lists. Okay, now my list itself is one list, and when I concatenate another list like 0, 5, 100, I'll get this list. Having said that, now again, if you're trying to print my list, you will not get this one again because you are not assigned this entire list to some other variable, right? So still you will be able to get the previous value how it was. So here that's exactly what is happening. Now, if I am assigning new list to my list plus this value, if I assign to another variable new list, then it will give me the complete result. There's nothing but the new list means it will give the values concatenated as well as the my list together. Now, if I want to check whether any of the value present within the list or not, so for that what I do, we have something called in keyword. So if I try to verify 63 in new list, means it will go to the new list and see whether 63 is available or not. It is there. So then it returns it value true. Similarly, if I give 167 in new list and it tries to see 167, it doesn't there, so it will give false. So now list of strings is nothing but A, B, C, D. In this case, if I want to remove one of the character like B, then I can use a remove function for the corresponding list value, list, and then try to remove the value. If I then try to print list of strings, by default, it will remove the value and assign the list of strings because by default this dot remove and dot add both things would actually hamper the actual list itself. So you do not need to again assign back to the corresponding list, right? So that is the difference between the assignment operator and your the intrinsic functions in the list. So similarly, sorted is also an intrinsic function in the list. So you can just use sorted to sort the entire list in a linear form. Actually, there's one more topic called tuples. Tuples and list, only difference I'll say is that tuples use angular brackets, and while list uses square brackets. Except that other important aspect over here, the tuples are also ordered, but it is unchangeable. What do you mean unchangeable? Here, actually, I was able to add, remove, and also if I want, I could replace the value. But in tuple, you cannot do that. Once you are assigned the value, that's it. So you cannot change the value again. So that is one important difference which you need to notice about the tuple. And also it allows duplicates, because ultimately here also you are assigning accessing through a assigning and accessing both through a indexes, right? So it doesn't matter here. So now if I try to print tuple value, and I try to put all three types of four types of data types on this string, floating, integer, as well as boolean. So all four things together, if I put a tuple value, then I try to print, also it will work. However, if I'm trying to print append another value to the tuple, it throws an error saying that tuple object has no attribute append, because append function doesn't exist. That's an interesting function which doesn't exist in the tuple. So you cannot use append, you cannot use remove. Those things and all you cannot do in the tuple. Having said that, you can actually use the tuple for variety of other things. Like suppose if I'm trying to assign temp tuple value with this like value 90.23 and all, then if I'm trying to assign set value with a similar thing, then try to print set value, then difference between a tuple and a set. Okay, which I think I should have given it here. No, haven't I given? Okay, I gave it here, I guess. Okay, so what I will do is I'll try to create a new row and tell the system where is it set marker. Meaning this is going to be counted as a comment, and please not add anything else. That is what I'm going to say here. Okay, so this again, just cut it, save it. So sets are unordered, okay, unchangeable, and does not allow duplicate values. What do you mean by unordered and unchangeable? Unordered means that you cannot access any set value using indexes. Number one. Number two, and unchangeable is similar to tuple. You cannot do any changes, or there is no interesting function like append or remove, anything like that. So in the one good thing about the set value is that you can actually, once you store the values and while retrieving the values, you'll be able to get the according to the priority. Like 222 is the integer, 90.222 is a floating point number. These are the two things which are going to be used extensively throughout the programs in most of the scenarios, right? So and true and value. True is mostly for assignment of it, and last will come as a string. So then, okay, so this is what I was trying to say. Set value to append a false return to, there's no object. Set value to equal to 45, true, 30.22, and true. So now if I put set value 2, I'll be able to get true, 30.22, and 45. Why I am not able to get true two times? Because it doesn't accept the duplicates, right? So means everything is whatever you have, everything in the set value is unique. It does not allow duplicate. So even if you are trying to assign duplicate values, by the default system thinks it has a single value, and it gives the corresponding output. Okay, so this is about set. Now let's quickly touch base upon dictionaries. So in the dictionaries, is also a collection which is ordered and that is ordered from 3.7 onward. That's what I was trying to say. And changeable, but no duplicates are allowed. Okay, that's the difference between the dictionary and the list or anything else. So in the dictionary also we generally use a flower basis, but here we will generally use a key value pair, because this is going to be key in most of the future programming. We could actually store all our objects in a key value pair, key value pair, and then store it in list. so that if you tomorrow if you want to trying to identify the value corresponding to the key, it's just a matter of putting the dictionary key and then getting the value. So similar to that, you can actually have we have intrinsic functions in the phone. Since I said this is possible to change, you can actually have some keys values and other intrinsic functions to actually check what is the key over there, what is the value over there, and all. So and also just to let you know, like you can actually have, since this dictionary is changeable, you can actually replace the value, you can add or remove whatever you want, right? So if I put the phones plus of 1 plus equal to 300, and then if I try to print phones system, though you can there's nothing like add remove per se, but when you are trying to assign the value, system knows that okay, since it is a dictionary, it is just going to have a what is called a key value pair, and it will directly append to the end. So that way you can actually append, change it. Okay, faces, sorry, phones of 1 plus equal to 400. So, yeah, so this one is actually replacing the value of 1 plus. 1 plus here I have given to 400. So tomorrow, if I'm trying to assign some other value, it will like 1 plus initially was 300. Then once I execute 400, it will become 400. So, similar what you call changes can be done using these dictionaries. And also you can actually delete a record in dictionary by giving delete phones of Nokia, because it's like a key value pair, right? So this based on this key, the both key and value pair will be deleted. So then when you're trying to execute that, so Nokia would have gone, then you would have seen iPhone, Samsung, and OnePlus. So this is about the list, tuples, sets, and dictionaries in Python. All types of collection classes. Now let's learn about the control flow statements in Python. So we have majorly for loop, while loop, and if else statements. So difference between the other programming language and the Python is in the for loop, we can actually give I mean, you can actually use both for procedural as well as object oriented, number one Python. But at the same time, suppose if there is this list with all these values, and if I'm trying to print the J in my list, and whenever you find a value J, then print J plus 2. So means the value, whatever is there, that value plus 2 is should print. So this, for that you can actually use for keyword and pass the corresponding variable which you are trying to do some calculation or operations in the list. If you say where to do, if you say the list, then system tries to print the value, and also it adds and then gives the corresponding output. So in this case, it will be like both 12 plus 2, 3, 6 plus 2, 3 plus 2, like that, and go on. Now, this is just about the for loops, right? So we also have something called as while loops, which I think I have not covered. Difference between the for loop and while loop. Okay, see. So while makes something happen when a condition becomes true. Okay, like if you have n equal to 0, and if you say while n is less than 8, n plus equal to 1 means what happens is n tries to increment the value to 1 and then tries to print the value. 1, 2, 3, similar until when it comes 9 is less than 8, then it comes out, because it's not, or 8 is less than 8, it doesn't come out. So it will 8 is less than 8 will never execute, and it is just a matter of if I put while n is less than or equal to 8, okay, that's a different thing, because at that time it would still execute. But if n is less than 8, then it will increment the n value up till there and then print the value. If the value comes out there, if 7 is less than 8, when it will execute all the way till 7 is less than 8, 7 equal to 7 plus 1, that means n equal become 8 and print n. So when during the next iteration when it becomes 9, this value entirely will fail and it will come out. So that's the reason why we get the value 1 to 8. Now, similar thing if you are trying to do with if conditions, we can also do that. But the only thing is that if conditions are a bit more tricky out here, because we need to understand not just about the skills or the technical aspect, but also about the logical way how it is represented. So if 10 is less than 1 is greater than 5, obviously 10 is more than 5 will print. But if 10 is greater than 14, print 10 is more than 14 will print. But if what you call 10 equal to 10 equals 10 means it's okay. But if can the 10 equal to 14 be possible? Answer is not. So if 10 is greater than 14, print 10 is more than 14. Otherwise, print 10 is less than 14. So instead of now giving 10, if you're giving some what is called as if you're going to give some other value, okay, a probably variable, and that variable is getting a value assigned from multiple places. Then if you're trying to print over here, then the corresponding, if the 10 is greater than 14, like that variable is greater than 14, then it will print that 10 is more than that variable. That variable is more than the 14. If that variable is less than 40, then we need to mention that that variable is less than 40. So that is how we can actually ensure if statements to be checked within the condition, within the program. Now, similarly, we can actually create a lot of exercises. So probably I will not have that much time. What I'll do, I'll just share these exercises for you to learn. Okay, if whoever wants it, please put it in the comment box. I'll just check and I'll forward you guys. So this is about introduction to Python. So are these the only thing which is required? Answer is no, because apart from this, we can also see about the other important aspects of Python. That is, getting started is, suppose we consider about swapping the variables, meaning we have checked the variable, okay. So variables are nothing but it can store any type of data type. So if we are assigning a value on Python with a string, then obviously the string, the data type of v1 will be a string. However, if we are trying to if we are asked to replace the string, what I would do is I will not be able to replace as it is, okay. So v1 to v2, v2 to v1. So what I will do, I will first create another temporary variable and assign the value v1 to the temporary variable. Okay, so now I can actually safely go and change the value of v1 with the v2. And at the end, what I will do, I'll use a temporary variable which I stored earlier and assign it back to v2. And this ensures that completely it is interchanged, and at the same time there are no issues. So this type of programming is going to give better insights on how to code better. So I request you to guys check out all these programs whenever it's available. Okay, this is about the swapping of two variables. Now, it's similar thing will happen of if when you're trying to print the values, print of v1 and v2, we get the value in the reverse order, because that's how we have mapped it again. Okay, so this is about Python basics. Now let's learn about getting started. Bear with me. Okay. So as you may be aware, we also provide the live trainings, personal live trainings, particular to your domain. So in this case, it's Python 3-M, VNV, and ENV. So what it does is that it actually tries to create a new environment, virtual environment, not physical environment, virtual environment for Python, so that none of the other projects or applications are being conflicting with it. And also is activate your virtual environment. So source, if VM is our virtual environment, so we what we'll do first, after we create a virtual environment, it is our job to activate it. Okay, if we do not activate it, then it's of no use of creating environment, right? So if this is for pure Python application, but if you are asked to do in the Anaconda, it's just a matter of creating a new virtual environment out there, and then use that virtual environment to trigger out the Python trainings, or sorry, Python, not Python, I'll say. Soon after the Anaconda, it actually creates a new virtual environment. It is just a matter of activating that particular environment. And then if all the other dependency packets are already there, then there's no issue. But if it is not, then it is better to install pip install --- upgrade pip. So this ensures that your package indexes are optimized and they're up to date. And also, once you have pip, then what you can do is you can install Jupyter, and also you can, if it's already available in the, I think if you're going to use in Anaconda, this will already be there. But in the scenarios where your project Anaconda, if it is not being used, then this is how you have to create a new environment in Anaconda. So similar functionality is almost similar for when you're trying to execute for both Python and Anaconda. So I will not take much time on this one. Rather, we'll see about the other important thing about functions and libraries. Okay, let me quickly take a pause and see if anybody has any questions. Okay, I don't think anybody has any questions. So what we'll do, we'll proceed further and see how we can, or where we can use Python functions. So Python functions, as I said earlier, even the basic print of hello is actually a Python function. So it's as simple as that. A function could be as simple as a print command. So now, if it is so primitive, then why what do you call it? Can the functions be used in every other aspect? What we saw earlier, it's just one of the type of functions. Like you can use get keywords and along with all the values that is there. But at the same time, you can also ensure that let us write a function like hello underscore me that asks for input of your name. Okay, then print hello for your name. So for that, what we'll do is we actually will create an input. We'll use input intrinsic method or function to assign the value to name, and then we'll use hello name, whatever the value it could come. Probably mostly it will come as a what do you call this floating point number, suppose. So we will try to convert into a hello string and then print the value. Okay, so if I'm going to do this, what it will do is it will give me an option what type of value it is there. So I'll give 12. So it will give me hello 12, right? Because it is interactive program where it will try to expect the value from us. Let us write a function called multiply two numbers that asks for input of two numbers and then prints their product. So multiply two numbers, and if it is this value, okay, for x also we'll get a value, y also will get a value, and then we'll try to sum it up. So what it will do is it will first get the value, and then it will try to print the value 12 into 22, which is 264. Right? This is about the advantage of Python, because you can use the same code in multiple places wherever it is being used and still ensure that same multiplication is carried out throughout. Now, we can actually create a function called square that takes number of argument and returns the square of the number. So square is nothing but like we'll create a new square. By default it doesn't exist in the standard library. So what we'll do, we'll create a function called square of a and then pass number to a square. Okay, now what happens is that when you're trying to pass a value 3.0, then it will actually change to 3.0 square. Okay, and also if it is suppose sum of squares and then pass 3.0 or 4.0, and then once you know that okay, this is a floating point number, but will this allow to do? Answer is square of a when you're trying to do again means actually that intrinsic functions which we have built earlier, that will do a power of and then return that. So in that case, 3 square is 9. 9 plus 4 square is 16. 16. 9 plus 16 is 25. So return sum should give 25. 25. That's why the reason why you are getting to 0.0 is because you are I think you have created a program, and that program, when it goes over there, it will still treat it as a floating point number and not as an integer. So, yeah, so this is about the Python basics. Now let's dive a bit deeper into Python. So, let us write a function called reverse underscore string, which prints the reverse of a string passed to it. Okay, so the call to the function is already included. So if I'm going to create a function called reverse of string and then along the string value, so in this case, string could be anything. It could be integer, it could be float, it could be any string which is being passed to it. Okay, so in this case, if I'm going to pass like this, okay, remove reverse the string. So at one shot, we may not be able to understand. But the beauty of Python over here is that since with the print function, if you are giving string value, a double colon from -1 means it is going to return the value when it is being used. So now if I try to say that, okay, I am trying to read the value from the reverse, okay, and then print the value. So this should give the values. This chimpanzee is of Gombe. So now, because the chimpanzee of Gombe is now read from the reverse one, because as I said earlier, it is about negative sign. Now, let us write a function called average. Okay, so what is average does is that it takes an argument and prints out the average values next. So now this is a function average of list, average equals 0, sum to 0 for I in list. So it will start from average 0 and sum, and then it is trying to sum the value of each of the values which is passed, and then once the sum is there, sum of length of list means every iteration, what is the sum and what is the list of average, both things we will try to print out. So now if I try to do this, okay, so I will be able to find that it is now value 872.7.6 because it has covered almost every other aspect of that average list, right? So now this is about average, average and how we can create a functions in Python. So having said, I see there are places where we need to be careful while creating a function name. There could be like identifier, which would be having similar other alternative names. So it is our responsibility to check whether the same name already exists or not. Okay, that is one thing which we need to be careful. Let us set a function called multiply underscore two numbers to multiply the numbers. Like here in this case, we are trying to multiply 1 and 2 and then print the sum. So this is entire sum which we are trying to print, and then we are also going to print the float number as well as another number. So in this case, n1 will be the value which I'm going to print. Suppose 34, and 2 will be the value 3, then the entire amount become less 7782.0. So I don't know whether it's amount also or not, but this is how it mentioned. So now let us, okay, so why this 782.0 has come? Because we have actually created as a float and then assigned to value n1. So if we do not put float and instead if we put integer or something, then it will actually convert that floating point to integer and then store the value. Okay, so that is the only difference. So now let us write a function called count underscore baser that takes two arguments. Okay, so the two arguments are one and there is two. The first argument is a DNA sequence. Okay, that's a DNA sequence are very complex. So it's like okay, let's see. And second is a string of the basis to be correlated. Okay, so how we can actually use the what do you call the DNA sequence to do our analysis, right? So now let's do one thing. Count underscore basis DNA underscore seq with AI. So we'll first try to see how much count it has. Next, we'll try to see how much count this AT has. Okay. So each of them, if there are more number of values, then you'll will be provided like length of one. So if 2 is blank, okay, so it means there are nothing which is passed, only always 1 is passed, then you take that 1, okay, you take that 1 and then print out. If there are more than 2, probably it will yeah, if 2 is blank, then count equal to length. So that means the one of them will be the count. Okay, so now if I execute that,
what will happen? So it will try to search AT, and blank in each of the values. That's called linear sequence. So now, since sometimes it may access, sometimes it may not access as well. In this case, it was accessing. That's a good thing. But there could be some scenarios where it could not be accessing. So we need to see what might not be the reason why it is being accessing one place and why not another place. So and also one important thing which I forgot to check and tell you is that if this doesn't work, then what we can do is we can actually even ensure that one dot count of two means we will explicitly mention that one will be like similar to like two. Okay, so this is nothing but one dot count of two. Okay, so let it. Okay, so now let us write a function called Fibonacci, which calculates Fibonacci series of the specified number. Okay, return the okay. So actually, this similar example has seen in C, C++, and other programming languages, where actually we are trying to loop through the same function again and again. So based on our what we call our requirement. So now let us create this what we call this function, and in this function we'll see what is the return value which is provided by this sequence of two values, and also sequence length. If it is less than one, only defines for length or one or greater. Okay, if sequence length is less than one. If sequence length lies in between 0 and 3, the return sequence of sequence underscore length will also be given the value. So now there are multiple things which we are trying to do. We are trying to see whether the value is 0 or not, and also whether the value is between 0 and 3. And also we're seeing that we're trying to append each of the values which we get. So first we'll try to execute this. Remember length 1 or greater. So length, okay, I have given length as 0. Okay, so what we can do is that we can ensure that missing parenthesis is called to print. Okay, so where is the print? Do you mean print of Fibonacci or not? Right? So what I'll do is I'll just directly write print here. If you see, I did not write what it needs to do, correct? So now if I get execute, I think there is some issue. Oh, well, it is not accepting is because I have not. So this was the old formatting. In the old formatting, you can actually use without brackets and without brackets as well. Okay, so now if I try to more, then I'll be able to get it, because in the earlier 2.8 and others print, if I print with a space, it would accept, but from 3.0 onwards, Python is specifically insisting to have an angular brackets in print. So yeah, so we were actually trying to create a Fibonacci series. Okay, so once the Fibonacci series is created, we'll try to call it. First, we'll try to import a random. This is nothing but a package, which I'll probably say in the next session, or okay, otherwise I'll just give you a small hint. Like we can have a lot of libraries, standard libraries. There are a lot of standard libraries, like random is one such thing. There are math. There are poly, so plots, pyplot, and there are a lot of plot. For all plots, you can actually get something called math plot lib. There are others like Cbon. A lot of packages exist which help us to create a what do you call it? If it is in the case of data science, it helps us to do exploratory data analysis. Okay. Now, so in this case, we are importing random. So So now a random becomes our group of similar set of instructions, and that becomes a standard library. That is already a standard library. That's not because it's a standard library which we are currently used. So now in this case, this actually creates as a this function guesses the randomly generated number and trying to random number equal random dot random int. So it is trying to randomly generate a value and assign to a random number. Okay. So now we will try to predict what would be the value in, so value should be present within 0 to 20. That's what we're saying, and we are assigning the random int 0 to 21 is up to that level we can actually assign the value to random number. Now this is a while loop, so it is trying to go again and again and again and again to see whether the values are existing between them or not. If it is not, then it will either print too small or too large, or it could even print enter the you have got in your corresponding values. Okay, let's try to see. Enter the value. Now let's say I'll put a value 10, too small. Okay, they accept a very high value. Now let's put 90, too large. So again, 23, too large. 24, 21, 20, 15, 11, too small. 12, 13. You have got it in 10 tries. So after every time I check and I was trying to figure out which time this random number of which I generate matches with this. So finally, after 10 tries, you got in 10 tries. I was able to decode it. So if you, I mean, there are chances that you will not get anything as well, but uh, don't be disheartened. That is how the program is being created, because we are trying to use all types of operations over here. We are trying to randomly generate the value and then trying to use it as well. So this is all about functions and libraries. So probably what I will do is that I'll quickly take a pause before I move back to the artificial intelligence course. By now, I hope you would have a good grasp on Python and how we can use Python, right? So Python alone mastering may not help. Python along with some other things also is helpful, but Python is definitely going to stay for quite a long time, right? And by now you would have seen the versatility of Python and how it is going to help us in all our future endeavors, right? Okay, let's come back to our previous PPT to wrap up the session. Okay, till now we discussed about Python. We discussed about Python basics, how it will be used in everything else, right? So we discussed about features of Python, where did it come from, the origins of Python, and also the starting of Python. So we also ensured that Python is running along with the Jupyter Notebook in using a software deployed package like Anaconda. We also learned about the various coding aspects of Python and learn how Python could magically reform ourselves, right? So, and also let's see about the future of Python, which I think is pretty important over here. Okay, so future of Python, according to I think this was published by I don't remember, probably Gartner, I guess. Yeah. So what they say is percentage of stack overflow question that month in Python is way too higher than any other thing. Because until 2012, people didn't have much idea about Python, where all it could be used. But as of today, Python has become almost like a de facto for data science. And hence,
if you see, the graph is going higher for Python while all other things are coming down. And I'm pretty sure graph will even move further exponentially as the time goes by. But at the same time, it is our job to match up to that and see that it is helpful for the humankind. Okay, this is all about future of Python. Let me switch back to my previous slide. Okay, so we missed some of the things like upcoming trends in AI. There are a lot of upcoming trends. You can just check it out. What is what's AI with R programming? So AI with R programming is good in those areas where it is statistical computing or data visualization purpose and all, because ecosystems, and that's the benefit of ecosystem in and also a picture says more than 1,000 words, right? So that is R lingua franca of AI. Now, R is slow. There are no doubt people would have got about risk present in the R programming. R is slow. R has a steep learning curve, no doubt, because initially it may start simple. It may look simple, but as the steam grows by, it obviously will need to be revisited. So now, what is AI with Python programming? This is what I said. Python is an open source, intuitive, object-oriented, extensible, portable, high-level programming language with dynamic semantics and GUI compatible filters. Now, IPython notebook is one thing which is very helpful, and also general multi-purpose language as well. So now, Python could be used for both general purpose as well as multi-purpose, and also it could be used for IPython notebooks that is built on top of Raspberry Pi. So now, risk visualizations is also risk, and as well as Python is becoming a challenger, and for R particularly. So visualizations and what called Python connectivity is also a risk, and which is present in the Python. Okay, what is machine learning in Azure? Azure provides AI and machine learning services that can naturally communicate with your users through vision, hearing, and speech. So I have used, I mean, used to do day in and day out, but now with Python, but now after the advent of machine learning in Azure, most of the repetitive tasks I try to use with machine learning in Azure, and only those tasks which need a thorough follow or thorough understanding of the customer, I'll pick it up. So it is a Azure AI is a cloud-based service for creating and managing machine learning solutions. Okay, it also provides storage solutions that dynamically grow to accommodate massive amounts of data. As the data increases, still our machine learning models should perform, right? So this is where machine learning Azure helps us. Okay, and by now you would be aware that ours is completely cloud-based servicing, and also we help manage machine learning solutions as well. Azure services can enable solutions that are not feasible without the power of the cloud. So there are areas where Azure services should not be used. Okay, but there are areas where it could be used. Azure service enables solutions that are not feasible without the power of the cloud. Okay, so you do not need a power of the cloud always. There is something called as a stick which you can use it to locally use the cloud as well for Azure. It designs to help data scientists and machine learning engineers to leverage their existing data processing and model development skills and framework as opposed to anything else. So machine learning Azure, yes, it is definitely helpful if you know Python, for sure, no doubt. But without learning a lot of Python also, probably once you start looking into the machine learning Azure, you will have a better idea. Okay, it also helps to them to scale, distribute, and deploy their workloads to the cloud. So machine learning Azure takes a bulk of it that's deployed to the cloud, and also ensuring that the workloads to the cloud is smooth and safe. And also one important aspect of machine learning Azure is that it could be reused, right? If suppose if I'm importing a data set for one particular experiment, so I could use the similar data set for the other set of experiment too. So do not worry if you are not aware of experiment or anything else. So probably you will have a better idea as you go ahead. Career path in AI. There are a lot of career paths. Like people mostly ones are like data scientists, and the other one is like data architect, data analyst, and process analyst. So process analyst is a I'll not say process analyst, but this like business analyst. They are ones who are generally present within the project. Okay, so they understand programming a bit, but also they understand more of a business. And a business, once they understand, then it is a data scientist. Data scientist responsibility to do ETL logic, advanced processing, and big data. So along with that, data scientist, there is something called one more entity called data architect, data warehousing, data architect level, data modeling, and they're all will come under data architecture. So this is where actually we are heading towards. And also analysis is like a beta again, product tech support, sales lead, and so on. There are a lot of other things also which are possible in the data analyst space. So data scientist is one thing, data analyst is one thing, data architect, as well as business target. So all four things are suitable career options for anyone to start off in the AI, right? So with this, we conclude our session on artificial intelligence crash course. If you have any other queries or concerns, please let me know. Yeah, you can also put in the chat window if you want. I quickly Okay, I do not think there is any queries as such. So why don't I request all of you guys to help AI, because AI is something which is very vastly unknown as of today. Even I'll not say AI is completely known entity. There are still some areas where which AI is going to be still worked on by various institutes and research enterprises. But having said that, if you would like to learn any aspect of AI, what other aspect of AI would you like to learn? This is what I would like to learn and understand from you guys. So if you can help us understand what other areas of AI would you like to learn in the comment box below. So probably we'll do a similar type of another session, and that could probably have more interactivity, and we'll see how we can have a better what you call I will try to utilize our time in a better manner and address all your concerns that may have. Okay, with this one, I think we are almost towards the end of the session. So thank you for joining for this session. If there is anything, I will again request you to put everything in the comments section below. Thanks for joining for today's session. Have a good day. Thank you.